Hello, good morning. Any questions from the previous class? सिमुलेशन का मतलब क्या था पहले तो? क्वेश्चन इज अबाउट क्वांटम सिमुलेशन. सिमुलेशन का क्या मतलब था? I was talking about simulations in the previous class. What does the word simulation mean? What does the word simulation mean? Anyone? Sorry? Okay, now we are on to something. Simulation can mean a lot of things. You're trying to understand how a system is going to evolve based on all the inputs which is given to you. सबसे सिंपल, जैसे मान लो सिमुलेशन को हम बहुत तरीके से यूज करते हैं. आपने जो बोला था वर्चुअल सिमुलेशन, सो यस सिमुलेशंस विल बी वर्चुअल, दैट गोज विदाउट सेइंग. जैसे फॉर एग्जांपल, think about, I have talked about in previous classes about Chandrayaan 3. Chandrayaan 3 का जो ऑर्बिट है, हम कब क्या करेंगे, all of that thing we have already decided that what are we going to do, and based on that we have programmed it. So how Chandrayaan 3, this entire setup is going to behave, we already have this information. Why we have this information? Because we have understanding about gravity, we have understanding about our own capability of the rocket, and at what point what we need to do so that we can finally deliver this into desirable orbit. So think of Chandrayaan 3 as a system, and how that system is going to evolve. It is going to develop once we launch it. But even before we actually launch it, we have to do all of that on a very powerful computer. That is what simulation is. In the previous classes, I have talked about how, let's say for example, we try to know about disasters. Cyclones के बारे में जैसे मैंने बताया था, that we already know cyclone, अगर मान लो cyclonic wind develop हो रहा है, then we already get a lot of information about it. How powerful it is, how is it going to move, when is it going to fall on the coastal land. All of that information we have beforehand. Why? Because we have gathered a lot of data about that cyclonic wind, and we are analyzing that data on computers, and we are trying to see how that is going to evolve. Or in the previous classes, I may have given the example of bridge. Think of a very large bridge and how it is going to behave if there are 100 cars and thousands cars. So simulations have very real applications. Simulation also can be as simple as you are playing a video game in a virtual simulation. That is also simulation. That you have some avatar, and in some avatar you are playing some video game in a simulation. That is also simulation. But when I'm using the word simulation in scientific research, the goal here is that how a system will evolve. We aim to know more about it based on all the data we already have, based on all the information we already have. Does that mean that we will be able to actually predict exactly how system is going to evolve? In many cases, no. Because if I have a very complex system and its evolution depends upon many parameters, and I do not have data about some parameters, then maybe I will not be able to do that really, really well. So quantum simulation means that think of all of the reactions which happen. Any reaction, chemical reaction which happens, fundamentally it is a change happening at atomic and molecular level. जैसे आपने सोडियम प्लस क्लोराइड तो बहुत सिंपल रिएक्शन आपने पढ़ लिया था केमिस्ट्री 9th में, but even that change is a quantum change. The fact that electron is transferring from sodium to chlorine, it may seem very simple, but that fundamentally is a quantum change. It is happening at the atomic level, and without appreciating quantum mechanics, we actually cannot explain that chemical reaction, even though it is a very simple chemical reaction. So quantum simulation simply means that when we have to simulate atoms and molecules, not talking about now Chandrayaan 3 or a bridge, I'm talking about simulation of atoms and molecules, whose behavior is guided by quantum mechanics. If we try to simulate that with help of, let's say, supercomputers, then yes, we will be able to do that up to some extent, but the moment more number of atoms, more number of molecules, the system becomes more and more complex, and my simulations will not be very accurate. And that is where quantum simulation comes into place. That with help of quantum computing, because quantum computing का जो underlying science है, वो quantum science है. And using quantum science now we can simulate atoms and molecules. So literally we can see that how group of atoms and molecules can lead to a new type of material. तो जो मैंने example दिया था that we can make new type of materials or medicines or things like that. That will be the potential of quantum simulation. That if we can understand how atoms and molecules will behave at quantum scale, then we have a lot of potential. How will we use it? Only future will tell, by the way, कि कितना ज़्यादा हम क्या हम बना पाएंगे. But अभी again I will repeat this what I said in the previous class that हम आस पास भी नहीं है. We are nowhere close to having this capability. Okay. How quantum helps in cybersecurity? How quantum technology helps in cybersecurity? That I haven't explained. In the previous class, I only talked about public key distribution. I told you that modern cybersecurity relies upon mathematical problems with this idea that these mathematical problems are very, very difficult to solve even by a very powerful supercomputer. ये हमने डिस्कस किया था. तो क्वांटम कंप्यूटर कैसे हेल्प करता है, क्वांटम टेक्नोलॉजी कैसे हेल्प करेगा साइबर सिक्योरिटी में, ये हमने डिस्कस किया नहीं है. आई एम गोइंग टू स्टार्ट टुडेस क्लास विद दैट. जस्ट फ्यू मोर क्वेश्चंस. Quantum computers are not good at solving small problems as compared to supercomputer. Yeah, so I will not say that they are not good at it. It's just that the impact of quantum computer which you want to see, it will not make any sense if you have simpler problems. Like for simpler problems, even simpler problems, I am assuming that you mean day-to-day life things. उसके लिए सुपर कंप्यूटर भी नहीं चाहिए, उसके लिए नॉर्मल कंप्यूटर भी चल जाएगा. But think of some complex problem which I talked about in previous classes, that we have to optimize a problem or we have to do climate modeling or weather forecasting, things like that. In such cases, we use supercomputers. Quantum computer का जो difference है compared to supercomputer, it only props up when we talk about large data sets, when we talk about very, very complex problem. So for simpler problems, whatever benefits quantum computers aim to provide, it will not make sense that you spend so much of money and you are solving it for simpler problems which could have been done by in almost the same time by some other computer. If you are spending a lot of money, millions of dollars, then it makes more sense that a quantum computer should be able to solve those problems which even a supercomputer cannot. So that is where the differences arise. That in certain type of problems, quantum computers are really, really good. In many other problems, they're as good as supercomputer, or maybe there are some problems which they cannot even solve. By the way, that is also something. Quantum algorithm is a very new thing. Computer science itna purana branch hai that we have developed, or computer scientists have developed, mathematicians have developed many type of algorithms to solve complex problem. But quantum computing is a relatively new branch. So quantum algorithm, set of instructions which can be used by qubits to solve a problem, that is in itself an emerging domain. So for a lot of problems, quantum computing may not be very helpful also. How private key is distributed, because it can also be breached like any other data. So private key is not distributed, that is the most important part. In the previous class, I talked about public key distribution. And the most important part here was that private key is not distributed. Private key is stored at your local device, at your local storage center. Private key is not distributed across a network. You only distribute your public key. That आपने लोगों को बता दिया दुनिया भर में कि ये मेरा encryption key है. जिसको भी भेजना है, मुझे कोई भी message भेजना है, use this encryption key. The private key to decrypt it, that is only for you. So you do not distribute your private key. But your question is valid, that even that can be, there are certain security flaws even in that. For example, a person who is impersonating some sort of receiver or a sender, and you are not able to, or your computing system is not able to distinguish between that. तो ऐसा नहीं कि public key distribution भी full proof है. There are security flaws there also. Breaking encryption simply means solving a puzzle. There is a question that we have discussed, breaking encryption. Can you explain that in short again? It's like solving a puzzle. That breaking encryption is learning a new language. आप समझ लो कि जब आप बड़े हो रहे थे तो आपको हिंदी, या मान लो कि you studied Hindi in your school days, and then suddenly you found out that a lot of people are talking in English, and that seemed gibberish to you, that what are they talking about? Or for example, think about any other language which you do not know, and think about how it may sound like to you. So that is why he talked about that. Think about people talking in Mandarin or some other language, Spanish, which you do not know, and that may sound gibberish to you. So that is basically that gibberish, but that is not gibberish. That gibberish is actually following certain protocol. There is a logic behind it. So that is decryption. Here will simply mean that you learn that logic. Jaise, when you learn Mandarin, then that Mandarin will not sound gibberish. That is a well-established language, very good language. When you learn Spanish, that's a very good language. So it was a puzzle because you did not know it. But the moment you know it, that puzzle is no longer a puzzle. So breaking encryption simply means solving a puzzle, but now it is a mathematical puzzle. And in day-to-day life, when we use puzzles or when we use any type of coding mechanism to encrypt data, they're not very complex. Like we can decrypt them quite easily. UPSC asks question that in CSAT paper 2. They expect you to decrypt a puzzle in a, like what, 1.5 or 2 minutes. 80 questions hai. एक question पे आप देख लो कितना time है. So they expect you to decrypt a puzzle in like 1.5 to 2 minutes using your brain, by the way, which is a very good computer. But then there are certain mathematical puzzles which forget about our brain. Even very powerful supercomputers cannot solve those puzzles. So जितना ज़्यादा हमारा ये जो encryption है, जो भी cryptography है, जितना strong होगा, उतना मुश्किल होगा to decrypt some sort of data, right? So in very simpler words, when I use the word encryption and decryption, it simply means that I'm using some sort of puzzle here to change my data in a way that only those who know how to solve this riddle, how to solve this puzzle, will be able to know what is being communicated, or what is that, what does that actually contain. If you do not have that, if you do not know how to solve that puzzle, then you cannot. It's as simple as that. Any other question if you have? Okay, quantum tunneling is a very specific phenomena. I'm not very sure that how it is important in this class, frankly, but फिर भी I will explain quantum tunneling briefly. Somebody else, किसी का और को कुछ, हाँ जी. That is something which we need to figure out. So the question he's asking is, that's a very relevant question. We need to design algorithms, verify, make. So question he's asking is that when many qubits are entangled, and when we want to do parallel processing, when we want all of those qubits to solve problem on my behalf, but I do not have to make changes on all of those qubits, I just have to make change to one qubit, and because all qubits are entangled with each other, they will solve problem on my behalf. That is where quantum algorithm बहुत important है. Set of instructions where all qubits based on your set of instructions are solving problem on your behalf, right? So that is where the skill set problem I talked about. हमने challenges last class में discuss किया था. One of the challenge I talked about is skill set problem. That is where skill set problem, that you are actually able to design an algorithm where there are thousands of qubits, and all those thousands of qubits are solving problem on your behalf with this postulate of quantum entanglement. I will repeat, there are already some well-established algorithms which people already are trying to use. Sure algorithm के बारे में मैंने last class में बताया, but there are many more. But we need to find more and more such algorithms which can be designed, which can use both superposition and entanglement together. Any other question? Quantum tunneling, I will not go into a lot of detail. In quantum mechanics, a lot of weird things happen. One of that weird thing here is, imagine you have to climb on a mountain. You started bicycling here. आपके पास bicycle है, and you have to climb this mountain. Imagine that this mountain has height h, but this height h is really, really huge, and you do not have enough energy. आप घर से खा के नहीं आए थे. You do not have enough energy that your energy, whatever energy you have or whatever energy you can spend on bicycling, that is not enough compared to, let's say, ये जो height के कारण जो भी potential है, this energy is less than potential V. Simple. So mountain का कुछ height है, height को cross करने के लिए you need to paddle your bicycle. There is E amount of energy available to you which you can spend on bicycling. But that E is less than the total potential energy which is represented by this mountain. You cannot cross this mountain. It's as simple as that. If your energy is less than some sort of potential barrier, you will be only remain at one side of the mountain. In quantum mechanics, if you have energy less greater than V, that's very simple. We can easily cross this mountain. In quantum mechanics, even when you have less energy than the potential barrier, you still can cross. Like we use the word tunneling, something like that, you tunneled through it, but tunneling को ऐसे मत imagine करो कि particle is actually literally making a tunnel. There is a finite probability that this particle will disappear from here and will appear here. There is a finite probability of that happening. It's a very low probability, but it's not zero. That even a particle which has less energy than some sort of barrier can be found on the other side of the barrier. And that probability is very less, but it is not zero. This particular phenomena is called quantum tunneling. It's like teleportation. आप इधर से आप disappear हुए और दूसरे side आप appear हो गए. तो इस बात होने की probability जो है zero नहीं है. It is a finite probability. This phenomena is called quantum tunneling. Quantum tunneling actually we do use, or we are trying to use in a lot of areas, but replicate quantum tunneling at technological level, that is very, very challenging. What is interference in quantum computer? Any type of changes to qubit. That qubit has contained some information into those superposition states of zeros and ones. But if that qubit is exposed to any type of disturbance, which can be atmospheric disturbance, temperature fluctuation, vibration, cosmic rays, any type of disturbance, and qubit starts losing its information, all of the information it has stored into it. So that will be what interference. In simpler words, supercomputer, quantum technology. In simpler words, supercomputers can be thought of as very, very powerful computing devices which can do calculations much, much more faster compared to typical day-to-day life computer. They use separate hardware, they use separate mechanism also to solve a problem, but still they process data into zeros and ones, into binary unit, when I am using the word supercomputer. In quantum computer, that's not the case. In quantum computer, when we are solving problem, we are now using qubits, quantum bits, which is superposition of 0 and 1. And those qubits can be entangled with each other, which means that one qubit, if you change one qubit, other qubits automatically change. This is the fundamental difference. So the underlying science of this computer and a supercomputer is same. How do we do the engineering part? That is different, but the underlying science is same. But in case of supercomputer or a normal computer versus quantum computer, the underlying science is different. Quantum computer does not follow postulates of classical mechanics, it follows postulates of quantum mechanics. And that is where the difference lies. But because of that difference, quantum computers can be made to a very powerful computing device, which I talked about in previous class. People often use a word called quantum supremacy. Give this heading, quantum supremacy. Write down a line. It signifies it signifies it signifies it signifies that a quantum computer can solve problems much faster than much faster than the fastest supercomputer So theoretically, researchers believe that a quantum computer will be much more powerful than a supercomputer. But practically it was demonstrated for the first time few years ago by Google's quantum computer called Sycamore. आप लिख सकते हो? Few years ago, Google's quantum computer Sycamore demonstrated it for the first time. For one problem. Demonstrated it for the first time. For one problem. ये प्रॉब्लम का कोई जो प्रॉब्लम जिसने गूगल साइकामोर ने जो सॉल्व किया था, इस प्रॉब्लम का कोई प्रैक्टिकल यूटिलिटी नहीं है. देयर इज नो प्रैक्टिकल एप्लीकेशन ऑफ दिस solving this problem. But even then, what we have accepted as a theory, or what was a theory that was confirmed by evidence, that a quantum computer will be much more powerful than a typical supercomputer also. So Google, when announced this, I think in 2017 or 18, they announced that the most powerful supercomputer would have taken few hundred years to solve this problem. A quantum computer did the same thing in about 120 seconds, so about 2 minutes. And that confirmed what people have always suspected, that a quantum computer will be much more powerful than supercomputer. But to actually solve it for real life problem without worrying about the error, all of that will take a lot of time. There is a question, and I totally appreciate this question. What does the word quantum mean? That's also a very good question, right? So Rajveer has asked this question. So I will answer this into two parts. As of now, it is a proper noun. So quantum mechanics, when I'm using the word, it is a proper noun. The same way you have your name, Rajveer, right? Something to call you, something to distinguish you from other people. Similarly, there are many branches of science. One of that branch, जैसे we call something called mechanics, optics, study of light is optics, study of electricity is like electromagnetism में we study electricity and magnetism. So one of the branch of physics is called quantum mechanics, where we study fundamental particles and their behaviors, nature at very smaller scale or at very colder scale. So as of now, quantum mechanics is a proper noun that I simply can define it as a branch of science which explains nature at very smaller scale. But हर proper noun का भी अपना कुछ etymology होगा, कुछ ना कुछ origin होगा. जैसे आपके parents ने आपका नाम राजवीर रखा, कुछ सोच के रखा होगा, बढ़िया नाम लग रहा है. So there must be some reasoning behind it. मेरे पेरेंट ने मेरा नाम अभिषेक रखा, उनको लगा बड़ा यूनिक नेम है, राइट? पत्थर फेंक देंगे इस क्लास में, कोई ना कोई अभिषेक मिल जाएगा यहाँ पे. So the point is that there are reasons. Maybe तब अमिताभ बच्चन ने अपने बेटे का नाम रखा था, इसलिए सब लोगों ने अपने बच्चे का नाम अभिषेक रखा था. Any reason can be there. So words have their own origin. So quantum mechanics can be thought of as a proper noun, a branch of physics which aims to explain nature at very smaller scale, but it does have an origin. That origin goes back to Einstein's theory when he talked about that light has a dual nature. When he talks about that how light is not just a wave but also behaves as a particle. So how Einstein hypothesized this, that when a light source emits light, then it is quanta of photons. Now quanta का मतलब होता है magnitude. That think of one group of photons, other group of photon, other group of photon, independent of each other. So whenever a light source is emanating light, it is emanating quanta of light, magnitude of light. वहाँ से word जो है quantum आता है. And then as of now, again I will repeat, we do not go into that etymology. As of now, quantum mechanics can be thought of as a proper noun. It simply is a branch of science which aims to explain nature at very smaller scale. Quantum in itself in English means I'm talking about some sort of magnitude. As an English word, quantum का मतलब होता है that I'm talking about some magnitude. Quantum of something, magnitude of something. Give the next heading, quantum communication. How nanotechnology is different from quantum technology? Quantum technology essentially is a branch of technology which aims to utilize quantum mechanics. Nanotechnology will be one of the application of that, because when we are talking about manipulation of nanoparticles, nanoparticle ka behavior is guided by quantum mechanics. I talked about that how nanoparticles, we are talking about something of few nanometer, at least in 1, 10, 50, 100 nanometer, we have to apply postulates of quantum mechanics. So to appreciate nanotechnology, we have to use quantum mechanics. But quantum technology in itself is a much bigger word, which means a lot of things. Nanotechnology essentially means manipulation of nature or making nanomaterials at very smaller scale, and from those nanomaterials try to make some nanocomposites or some other type of devices, things like that. But to make those devices, to make those materials, we need to have good understanding of quantum mechanics also. So there is an overlap here. I have talked about this a number of times. How normal computer is related to Newtonian mechanics. I will not say Newtonian mechanics, but I will say that the postulates they follow classical mechanics. Newtonian mechanics is a like small part of classical mechanics. That here when we represent data, data is 0 or 1. It cannot be both 0 and 1 together. In our day-to-day life, we can never imagine one object occupying two spaces together. That is what quantum mechanics tells us, that an electron is at two or more than two locations simultaneously, albeit with different probability. That is the fundamental difference in classical mechanics and quantum mechanics. So in supercomputers, when they are solving a problem, mathematical problem, they will not do that maybe I have something called which is both 0 and 1 together. It's not just possible. So we are still dealing with classical world, how we think of world, how world behaves, that either it is or it is not. But in quantum mechanics, it is both it is and it is not simultaneously. So quantum mechanics का वो fundamental departure है, and that is where quantum computer का जो working है, that is based on postulates of quantum mechanics. Give this heading quantum communication. It's not important what Sycamore demonstrated and what is the information we get from this. It's not important. It's simply, in fact, let me tell you what the problem was. The problem was that let's try to do quantum simulation on a supercomputer, and let's try to do a quantum simulation on a quantum computer. And up till few qubits, 50 qubits, the performance of supercomputer and quantum computer was almost neck to neck. But with Sycamore, which it was made into 53 qubit, and suddenly that performance became 1,000 times faster than supercomputer. So it was a quantum simulation problem, but that quantum simulation problem was not that important problem. And the problem was very simple, that can we do quantum simulation on a supercomputer? The answer is yes, we can, but there will be a lot of limitations. If your system becomes more complex, we cannot do that. And that is what was demonstrated by Sycamore, that you cannot do quantum simulation on a supercomputer beyond certain level. Write down few things in quantum communication. In quantum communication, postulates of quantum mechanics, such as superposition and entanglement, postulates of quantum mechanics, such as, बोलना एक जरा मुझे पेन ड्राइव चाहिए, such as superposition and entanglement are used to secure data, and for information processing, For example, quantum key distribution. Let me explain this a little bit. The actual mechanism is difficult to appreciate without, अभी तक क्वांटम कंप्यूटिंग में तो चलो फिर भी हमने क्वांटम मेजरमेंट कैसे करते हैं सारी चीज़ों पे वी हैवंट एक्चुअली delved into that. It was not required also. To appreciate quantum key distribution, we actually need to know something called quantum measurement. That what does the word quantum measurement mean? How do we measure a quantum state? I will not go into that because that will make topic very complicated. But think of the earlier problem. In the earlier problem, I talked about Alice and Bob sharing a secret key using some sort of mathematical formula here for encryption or decryption. And Eve, short of eavesdropper, and Eve will not be able to make sense of it because Eve does not have the decryption key. But now Eve has a quantum computer. Eve had somehow gotten access to quantum computer, and that quantum computer can find the prime factor of a very large number in a very small amount of time. So this public key distribution based on some mathematical problem no longer is safe. What Alice and Bob will now do here is that they will use something called quantum key. Rather than public key, they will use postulates of quantum mechanics. They will share a key in qubits. They will make some qubits and they will share with each other. Alice will make a qubit, will send it to Bob. Bob will measure that qubit. And they keep doing that many number of times. But then Alice and Bob on a classical channel. So they will share that key with help of, let's say, optical fiber cable. Or they can also use space. So for that, they can use satellites. So Alice has designed a qubit, and that qubit has been sent to Bob with help of either. And how, for example, one of the most famous way to send that qubit will be a photon, a polarized photon. Photon which is polarized. Polarization, I talked about that in previous class. Polarization is where electric field of electromagnetic wave is not vibrating randomly. It is vibrating into some fixed direction. That is called polarized light. So to design this qubit, Alice used polarized photon to Bob. Bob measured that. And they kept doing that for quite some time. After that, on a classical channel, not on a quantum channel, they actually matched each other, that what I sent, what you measured. There is a proper protocol, like what Alice sent and what Bob measured. If there was no Eve, then they will immediately know that koi yahan pe eavesdropper nahi hai. But if there is an Eve who was trying to intercept this photon, who was also trying to make changes to that, who was also trying to figure out what that photon polarization is, then that essentially will change the quantum state. And when Alice and Bob matches their key later, they will figure out that there is an Eve here. So the underlying science of quantum key distribution here is that whenever there is an Eve, Eve has to find out the decryption key. To find out that decryption key, Eve has to measure the qubit, but the act of measurement changes the qubit. And that alerts both Alice and Bob that somebody has tampered with the key and there is an eavesdropper present in the network who has, by the way, been able to measure this qubit many times. But they will always know beforehand, before they can actually use this key, they will always know that there is an Eve here. Because Eve, to know the decryption key, has to measure this qubit, and the act of measurement changes the qubit. तो इसका जो सबसे fundamental underlying science इसका जो है, बहुत सिंपल है कि जो क्यूबिट है अगर आप उसको मेजर करोगे वो चेंज हो जाएगा. इट विल नॉट बी द सेम क्यूबिट. एंड एलिस नोज व्हाट वाज द ओरिजिनल क्यूबिट एलिस सेंट. Bob knows what did Bob measure. And Alice and Bob will know that if there is an Eve present in the network, and if there is an Eve present in the network, they will disregard that key, they will share some other key. So even before Eve could do anything for decryption, Alice and Bob always will know that there is an Eve present in the network. So it actually uses quite an ingenious method. No longer we have to go into complicated mathematical problem. It uses a fundamental quantum postulate that the act of measurement changes things. If you are measuring something, I talked about that a lot in the previous class, that how in quantum mechanics, the act of measurement changes things. So fundamentally, because the act of measurement changes things, that is going to alert both Alice and Bob that this key encryption key has been tampered with, and they are simply not going to use that key. So even before Eve could do anything, both Alice and Bob knows that this key has been tampered with. To share that key, they can use optical fiber cable, or they can also use satellite. Optical fiber cable का problem क्या है? That photon can be absorbed by the cable itself. But satellite, if you are using space as a medium, then that satellite, that photon can travel much larger distance here. The problem here is that atmosphere is also going to cause a lot of problem to that photon. Remember, qubits are very sensitive. So how to rectify that? That is something, a challenge, and there a lot of work is happening. That how can we rectify this problem where we can establish a quantum key distribution across a larger channel. Using optical fiber cable, people have been able to establish quantum key distribution with like few 100 kilometers. Even in India, I remember few years ago, IIT Delhi collaborated with DRDO, and they were able to establish a quantum key distribution of 50 kilometers, right? So IIT Delhi is my alma mater, so because of that, whatever it does, I'm very much interested in it. So quantum key distribution was established with a range of 100 kilometers. And if you try to increase that range, let's say if you want to now share that key for 1000 kilometers or 2000 kilometers, then there is a fear that this photon will be absorbed. So जितना ज़्यादा distance होगा, quantum key distribution करा पाना उतना ही मुश्किल होगा. And that is where satellites come into place. In previous class, somebody was asking this question, that what will be the role of this satellite? The role of this satellite will be to create a communication channel where that encryption key can be shared between Alice and Bob without worrying about that this light will be absorbed by optical fiber cable. So इस पूरे टॉपिक में हमको बस ये याद रखना है that if there is an eavesdropper, then that eavesdropper has to measure the qubit to know the decryption key, but the act of measurement changes that qubit, which alerts both Alice and Bob. एक लाइन में बस हमको याद रखना है कि ये क्वांटम की डिस्ट्रीब्यूशन क्या है. इसका कोई काट नहीं है, इसका कोई क्वांटम कंप्यूटर हो, कुछ भी हो, इसका कोई काट नहीं है. This literally is a secure channel of communication. So lot of countries and lot of companies, they already are investing a lot of money in quantum key distribution, that in future when quantum computer becomes a reality, we have to prepare ourselves for that post-quantum world, where all of our data is going to be threatened with this powerful, humongous capability of quantum computer. And then we need to find something else to secure our data. And quantum mechanics again comes to rescue here. So write down a few things here. In QKD, two parties. In QKD, quantum key distribution. In QKD, two parties can create a shared random key. Can create a shared random key. Random key to encrypt and decrypt messages. To encrypt and decrypt messages. For this, they can use, for this, they can use qubits, qubits. सबसे फेमस वे टू डिजाइन क्यूबिट इस केस में जो होगा वो होगा फोटोन का पोलराइजेशन. जो फोटोन का पोलराइजेशन है वो क्वांटम फिनोमेना है, and that will be the most important way to design a qubit in this case. No need to write that. Write down the next bullet point. The security comes from the fact. The security comes from the fact. From the fact that any attempt to eavesdrop, that any attempt to eavesdrop would disturb the quantum states, would disturb the quantum states. Any attempt to eavesdrop would disturb the quantum states, alerting both sender and receiver. Alerting both sender and receiver would disturb the quantum state, alerting both sender and receiver. To share the secret key, to share the secret key, optical fiber cables, optical fiber cables, or even satellites can be used, or even satellites can be used. This is more than enough to know in this topic. I will keep repeating this no matter how difficult it looks like, or it is a difficult topic, goes without saying. But the questions will be very simple. And इस पूरे टॉपिक में क्वांटम की डिस्ट्रीब्यूशन में जो सबसे की लाइन हमको याद रखना है वो ये है that if there is an eavesdropper, somebody for which this message was not intended, and if that eavesdropper aims to know what the message is actually being transmitted, what is the decryption key, then it will alert both Alice and Bob, because eavesdropper has to measure the quantum state, and the act of measurement changes the quantum state. And that will alert both Alice and Bob. They will always and always know beforehand, even before encrypting, they will always know that there is an Eve present in the network. And they will not use that particular key. And that is why, so few countries I will name here. America, which has, as of now, like the best capability in quantum communication, but China is very close by. So China is investing lot of money in securing their channel of communication. So quantum satellite, which India is planning to launch in next few years, China launched few years ago. Like in 2017, I came across a news that China has launched a satellite जिसका purpose यही है that can we establish a quantum key distribution. Rus is also not very far behind. So Russia is also investing a lot of money. Germany, France, UK, these three are other countries which are investing a lot of money. So many developed part of the world, along with China and now India also, they are investing a lot of resources in establishing quantum communication network where we can have a secure channel of communication without worrying about that somebody will figure it out. So quantum key distribution allows you to achieve that. The challenge here is that जितना ज़्यादा distance बढ़ेगा sender receiver के बीच में, उतना ज़्यादा मुश्किल होगा इस key को share करना. How to overcome that challenge? That is where a lot of work is happening. And that is why this national quantum mission, which we talked about in last class, is important. Give the heading quantum sensing and metrology. Your question is actually a very important question. But to answer that, we need to know what the word quantum measurement means and what will be the result of quantum measurement, which is not required. आप बस एक आप ये जो मैंने एक लाइन बताया था ना, हमको जो एक लाइन याद रखना है यहाँ पे, that if there is an eavesdropper, it will alert both sender and receiver. Simple. ये हम एक लाइन याद रखेंगे that if there is an eavesdropper, eavesdropper has to measure the quantum state and it will alert both sender and receiver. Right. So ये बस हम याद रखेंगे. बाकी do not worry about like how receiver is going to measure. What will that do to quantum state? I know that that is the question you are asking. That's actually a very good question, but we cannot. Like, this is beyond the scope of this class. Like, do you have some understanding of quantum mechanics? So I could have so ask me after the class. I can answer that. Anyways, give the next heading: quantum sensing and metrology. This is one of the most successful branch of quantum technology, one of the least talked branch of quantum technology. Quantum metrology, by the way, it's science of measurement, making science of accurate measurement. Science without measurement does not make any sense. Just say whenever you have done experiments, even in your school days or college days, a very important part of that experiment was how to minimize the error. How do you actually measure from vernier caliper, or how you look at how much solution is there in a particular container. There is a way to measure that. And we tried to conduct same experiment few number of times. somewhere error is less than measurement, somewhere more than measurement, you take the average value, you get the idea that we, हमारा एक बहुत बड़ा focus experiments में क्या होगा, that how to take the correct data. Now at very smaller scale, when you try to take the correct data, even a small change, which is very small in our frame of reference, but that is actually a very huge margin of error. That you are measuring, let's say for example, some sort of chemical bond to be 10 angstrom, where it is only 8 angstrom. Now that difference is only 2 angstrom, which does not make sense to us, to our human brain. 2 angstrom is nothing. But that 8 to 10 जो difference है, वो जो margin of error है इतना ज़्यादा है that this cannot be ignored. That percentage error is really, really high. Turns out that quantum sensors and quantum devices which are used for measurement, they are really, really good at measurement. They are really good at measuring things with very, very high accuracy. And I will give you many examples of that. The best example is something called atomic clocks. How does a normal clock works? बहुत सारे लोगों ने घड़ी पहन रखी है. How does this work? How does that 1 second जो move करता है, that is only 1 second and not something else? How does this watch knows that? Quartz crystal. What about quartz crystal? Perfect. There is, if you go and open this clock, at internal part of it, you are going to come across a crystal, particularly a very special type of crystal, which is called quartz crystal. Quartz is nothing but silicon dioxide, SiO2. That silicon dioxide, when it takes a crystal form, it becomes something called piezoelectric material. Piezoelectric का मतलब होता है कि अगर आप किसी चीज को thermal stress दो, आप उसको press करो, compress करो, it produces electricity. इसका जो सबसे बढ़िया एग्जांपल है पीजो इलेक्ट्रिसिटी का, वो आपके घरों में जो गैस लाइटर है वो है. गैस लाइटर को आप प्रेस करते हो, it leads to that spark. That is the best example of piezoelectricity. That if you look at, open that gas lighter, you will find again that quartz crystal. When you press it, you are actually compressing it, which leads to basically emission of electron. That electron does not find a circuit, but it does jump. But that jumping releases a spark. It leads to a spark, a very small light here. That is more than enough to burn your burner. So piezoelectricity in itself is a very amazing phenomena, where when you compress something, it produces an electricity. So this quartz crystal has a mechanism where all the time it actually produces, it is being compressed. But after that, quartz crystal starts vibrating. एंड जो क्वार्ट्ज क्रिस्टल का जो वाइब्रेशन है वो फिक्स्ड है. वो 1 सेकेंड में कितनी बार वाइब्रेट होगा वो फिक्स्ड है. जैसे मान लेते हैं फॉर सिंप्लिसिटी कि 1 सेकेंड में 100 बार वाइब्रेट होता है. ऑल्दो 100 बार नहीं है, एक्चुअल नंबर इज into few thousand. I have forgotten what is the actual number, but for simplicity let's assume that there is a quartz crystal. When it is subjected to mechanical stress, it starts vibrating, and that vibration is 100 times per second. But now with that quartz crystal we have connected lot of gears. आपने घड़ी में देखा होगा छोटे छोटे gears होते हैं, बड़े small से gears होते हैं. All of those gears are connected to each other, जिनका goal finally ये है that ये जो second stick है, that final gear is connected to that second का जो stick है. And even though the first gear was moving with frequency of that crystal, but the final gear which is connected to that second stick, उसका frequency है 1 in 1 second. So the gear connected to the crystal, that had the frequency of the crystal, but the gear which is connected to this second stick, that has the frequency of 1 vibration 1 second. So when that 1 second moves, you can be assured of the fact that it actually is 1 second, what we have decided as a unit. From that second you have minute, 60 times it moves, minute moves 1 times. From that you have hour stick, 60 times that moves, hour stick moves 1 time. So fundamentally it depends upon the vibration of quartz crystal, and quartz crystal का जो vibration है, that is not affected a lot by atmospheric parameter, but it can be affected, or there can be some problem in your gears also. ये जो घड़ी है, I am going to wear it for, I don't know how long I'm going to live, maybe for next 30 years, I hope. So, right? I really hope that 30 years I die. In 30 years I die. So let's say that I live for more than 30 years. And for those 30 years, this clock will perhaps slow down or fasten up by a few seconds. It's not a big deal, right? But I remember my father used to wear a watch, and वो हर 2 महीने में 5 सेकेंड या 1 मिनट कम हो जाता था, स्लो हो जाता था. उसमें पानी में थोड़ा सा भी पानी आ जाए, ओस गिर जाए, it used to absorb that moisture, and it used to slow down or fasten up. And every few months he had to go to a shop, and that shop, तब खाली HMT घड़ी बनाती थी. सरकार को सब कुछ करना है, घड़ी भी बनाना है, तो HMT घड़ी बनाती थी. Now this, we do not suffer from this problem in our modern watches. But even this has error. The only problem is that this error is so less that in our lifetime that error is basically ignored. You do not have to worry about it. So quartz crystal vibration can be affected, and particularly जो आपका पूरा gear है, जो पूरा machinery है घड़ी का, that can be affected. And that is why just relying upon quartz crystal may not be a good thing. In atomic clocks, what scientists use here is that they use vibration of certain atoms. Certain atoms, when they are subjected to some energy, and when they start vibrating, then उसका जो frequency है वो बिल्कुल fixed है. जो सबसे famous atom है वो cesium है. They use cesium, and cesium atom का जो vibration है वो fixed है. वो 1 सेकेंड में कुछ vibration होगा. वो आप दुनिया में कहीं चले जाओ, आप universe में कहीं चले जाओ, as far as our understanding goes, that vibration will not be affected. So now we correct our time, whatever error quartz crystal is having, we can correct that with this very fixed mechanism where we are using cesium clock. जैसे आपको न्यूज़ में दिखेगा that जो नाविक है या GPS receivers हैं, they are using atomic clocks. Now why they are using atomic clocks? Because they have to measure time in very, very high precision. And इसको appreciate करना बहुत आसान है. जैसे मान लो there is a GPS satellite. For simplicity, I am assuming that it is at 30,000 kilometers from surface, which is not, but for simplicity, so that my calculations are easier, let's make this calculation. I told you in the previous class that I need 4 such satellites to determine the precise location of somewhere on planet Earth. And I also told you that it fundamentally does by measuring the distance. But how does it measure the distance? It measures the distance by measuring the time which has taken a particular light pulse to arrive to a particular receiver. That I have a GPS receiver, that GPS receiver received a signal from a GPS satellite. That signal essentially is radio signal. It is going to travel with 3 lakh kilometers per second. So how much time this is going to take? 30,000 kilometers divided by 3 lakh kilometers per second. This is going to take 1 by 10 seconds. नहीं होगा ना? So if the signal has reached in 1 by 10 seconds, the satellite knows that from this satellite, this GPS receiver on planet Earth is 30,000 kilometers far away. But that GPS का जो time measurement है, that was based on quartz crystal. Turns out this quartz crystal has a problem. It has an error. It has an error of, let's say, 1 by 1 lakh second. That for every 1 second, it has an error of 1 by 1 lakh second. Now 1 plus 1 by 1 lakh is 1 only. For all practical purposes, it is 1 only. At least in our day-to-day life, 1 by 1 lakh second is very, very close to 0 only. I can ignore that error. But can the satellite ignore that error? It cannot, because rather than measuring 1 by 10 second, it now measured 1 by 10 second plus 1 by 1 by 1 lakh second, 1 by 10 plus 1 by 1 lakh second. So now this is going to measure divided by 3 lakh kilometer. So rather than measuring 30,000 kilometer, now it is what it is going to measure? 30,000 plus 1 by 1 lakh into 3 lakh, 3 kilometer. So it is not going to measure 30,000. It is going to measure 30,000 kilometer plus 3 kilometer. So this satellite now has an error of 3 kilometer. I am here, but satellite is telling me that I can be anywhere from where I am into a 3 kilometer radius. Can that be ignored now for a satellite? The answer is we cannot. We want an accuracy of centimeter. हमको accuracy centimeter में चाहिए, 5 सेंटीमीटर, 10 सेंटीमीटर, 15 सेंटीमीटर, ये accuracy चाहिए. So what seemed like a very small error in our day-to-day life applications is a huge error when we talk about GPS satellites or space applications. In fact, whenever we do scientific research, there are a lot of very precise scientific research going on all across the world. Measuring very precise time is very, very important. Think of those radioisotopes जिनका half life जो है 1/1 million second है. Rather than measuring 1/1 million, you are measuring 1/10,000. That's a 10 times error, not at all acceptable. So making precise time is very, very important in scientific research. So we use atomic clocks. And जो cesium atom का जो fixed vibration है, that you cannot appreciate without understanding quantum mechanics. That why cesium atom is vibrating with exactly same frequency and why that frequency will always be the same. That essentially is a quantum phenomena. So with help of quantum sensors, we can measure distances, magnetic field, gravity also, time also, with very, very high accuracy, which is not possible with help of the typical devices which we use in our day-to-day life. This is actually one branch of quantum technology, which is the most popular and the most useful one. But measurement is not very romantic. Like I'm measuring things, that's not very romantic. So it's not covered a lot into newspaper versus if somebody is talking about quantum communication, quantum computer, that has a lot of like romance associated with it, and because of that, that often is given a lot of coverage. But this will be perhaps the most successful branch of quantum technology, which we already are using. This already has a lot of application in scientific research, in GPS receivers, in so many different areas. So you can write down a few things here. This involves use of quantum systems. This involves use of quantum systems. Quantum systems, phenomena, to make measurements more accurate than classical systems allow. Quantum sensors can detect. Write down in next paragraph. For example, quantum sensors can detect extremely small magnetic field. Extremely small magnetic field. किसी ने टर्म सुन रखा है इलेक्ट्रोएंसेफेलोग्राफी, EEG? क्या होता है EEG? क्या होता है? ब्रेन वेव को मेजर करते हैं. ओके, सो आपने फिल्मों में देखा होगा कि पुलिस ने बुला रखा है किसी को, बहुत सारे ब्रेन पे इलेक्ट्रोड्स लगा रखे हैं, और फिर पुलिस इज ट्राइंग टू फिगर आउट दैट ये जो इंसान है झूठ बोल रहा है सच बोल रहा है, राइट? दैट इवन व्हेन यू आर स्पीकिंग ट्रूथ और यू आर नॉट स्पीकिंग ट्रूथ, देन whatever your, like what you are saying versus the activity in your brain, that can be intercepted with help of electrodes. That there is a very small electrical activity going on inside your brain, and that device, that electrode around your brain aims to measure that. When you lie, then the part of brain which becomes activated, brain becomes much more active compared to when you are telling the truth, because truth does not require any effort. When you lie, you have to make up things, and when you have to make up things, the part of the brain which becomes active, that can be recorded with help of that EEG. But then we also use magnetoencephalography, that there are electrical and magnetical change which are going on in your brain, and even with electrodes or magnetic devices outside your brain, they can monitor that brain activity. People have now taken this one step further. We have something called brain computer interface. पढ़ा होगा आपने. अभी थोड़े दिन पहले इलान मस्क की जो कंपनी है न्यूरालिंक, उन्होंने अनाउंस किया that they have implanted a brain chip inside a patient, and now he was playing chess. A person who went into an accident completely lost ability in lower body part below shoulder, and now the person can play chess only with his brain. There is a chip implanted. That chip allows him to interact with that computer, that it's sending a signal to the computer, not even speaking, sending a signal to the computer, and computer knows what that signal is and implements that signal. So ये भी यहाँ तक भी टेक्नोलॉजी पहुँच चुका है. But in this specific case, when I talked about use of quantum sensor, it can measure even very small changes in magnetic activity in your brain. Second, you can write on example. Atomic clocks are using quantum principles. Atomic clocks are using quantum principles to maintain extremely stable time references. To maintain extremely stable time references. Which are critical for GPS systems, scientific research, among others. Which are critical for GPS systems, scientific research, among others. You can write down few more things about atomic clocks. Atomic clocks rely on vibrations of atoms. Atomic clocks rely on vibrations of atoms, such as cesium or rubidium. Such as cesium or rubidium. Rubidium. The frequency of such vibrations, is incredibly stable and precise. Is incredibly stable and precise. Is incredibly stable and precise. अब यही चीज अगर हम क्वार्ट्ज क्रिस्टल यूज करें, that vibration is going to change depending upon atmospheric parameter, depending upon the stress it is subjected to, and that is why quartz crystal is a very good thing in our day-to-day life, but for very precise timing it cannot be relied upon. With all of this information, you can write one last line in this entire topic. National Quantum Mission aims to write down in bullet points. Develop a quantum computer. With 50 to 1000 qubits. 50 to 1000 qubits. Next, satellite-based secure quantum communication. Satellite-based secure quantum communication. Satellite-based secure quantum communication over a range of 2000 kilometer. Over a range of 2000 kilometer. Third, intercity quantum key distribution over 2000 kilometer. Intercity quantum key distribution over 2000 kilometer. Over 2000 kilometer. And one last, developing quantum materials and devices. developing quantum materials and devices, for example, atomic clocks. Atomic clocks. I already have told you this will be implemented by Department of Science and Technology. 8 साल का हमारा मिशन है. 2023 was the starting period. Will continue till 2031. So that is the timeline of the mission with a budget of 8,000 crore rupees to be implemented by Department of Science and Technology. So ये भी एक पता होना चाहिए हमको prelims या mains examination के perspective से. There are few questions here. Quantum computer helps in finding out suitable drugs through permutation combination. My question is how it will work like for drug test. So clinical trial, the question is that when we talk about discovery of medicine, and how quantum computer will help in clinical trial. Not in clinical trial. But clinical trial हम random चीज़ों पे थोड़ी शुरू कर देते हैं. जैसे मान लो कोई फार्मा कंपनी है, ऐसा तो नहीं कि कुछ भी उठा के देखते हैं कि इसका ह्यूमन बीइंग पे क्या इम्पैक्ट होगा. They have to first do this trial. They have to first do molecular simulations. That let's look at biomolecules, let's look at this medicine and how those biomolecules will behave when they are subjected to medicine. So this will be done first on a computer, then on perhaps some tissues into lab, then onto some animal. So clinical trial done on human being will last phase hoga. No medicine will be approved without conducting clinical trial. But clinical trial stage tak pahunchne ke liye, what type of medicine will be helpful? Their quantum computer is going to help you. America already has successfully achieved quantum communication. Okay, so successfully तो India ने भी achieve कर लिया वैसे quantum के distribution, but there are limitations in terms of how much data can be transferred and for how much distance it can be transferred. And that limitation, America is better than perhaps China, and China is better than India, but all of the countries are suffering from the challenges that जितना ज़्यादा range होगा उतना ज़्यादा मुश्किल होगा, and how to take care of that. So that problem all of the countries are facing. India, Russia, China is trying to achieve quantum communication. Many other countries, not just India, Russia, China, almost all Western European nations, जिसके पास भी capability है, resources हैं, they are trying to establish quantum communication. LIDAR. So yeah, LIDAR में भी जो बहुत precise timing measurement है, that uses atomic clock. Yeah, that is there. LIDAR is a GPS enabled device. Light detection ranging जो हमने discuss किया था remote sensing के case में. So that is actually a GPS enabled device, and that does use atomic clocks to know the very precise measurement of how much time it takes for a particular light pulse to be reflected from a surface. $50 to 1,000 का मतलब यहाँ पे ये है that 50 minimum, but hopefully even 1,000 qubit. 50 to 1,000 का मतलब ये है that जो हम क्वांटम कंप्यूटर बनाएंगे हो सकता है 50 qubit का हो, वो मिनिमम रिक्वायरमेंट है हमारा, बट होपफुली मैक्सिमम हम 1,000 और उससे भी ज़्यादा हम जा सकते हैं, बट 1,000 qubit तक का हम क्वांटम कंप्यूटर बनाएंगे. दैट इज द मीनिंग ऑफ 50 to 1,000. IBM का ऑनलाइन क्वांटम कंप्यूटर है, बट IBM का जो ऑनलाइन क्वांटम कंप्यूटर है दैट एक्चुअली अलाउज यू टू डिजाइन क्वांटम एल्गोरिथम्स एंड रन क्वांटम एल्गोरिथम्स. So if you want to learn more about quantum computing, then yes, IBM has a lot of free resources available and you can do that. थोड़ा एक simpler topic discuss करते हैं next. Give the heading artificial intelligence. I promise this will be a simpler topic compared to the previous one. I will start with a very simple question. What does the word intelligence mean? I'll come to the artificial intelligence part later. But let's try to understand the meaning of the word intelligence only. That we call ourselves intelligent. हमारे frame of reference में we are intelligent, कोई doubt नहीं है. हमारा frame of reference Earth तक limited है. On Earth we are perhaps, not perhaps, we are the most intelligent species. But what makes us intelligent? Like what are some of the attributes which makes us intelligent, which is not available in case of other animals? Presence of consciousness. Okay, that's a fantastic start. Do we know what is consciousness? We actually do not know what is consciousness. That's also one of the most interesting thing about the more we study about neurology, we realize that we understand very little about consciousness, like what makes us conscious. The fact that we are aware about our surrounding, we can do complex calculations. Conscience की मैं बात करने ही कर रहा था मैं. So I hope that we are not confusing with conscience versus consciousness. Conscience is that ability to take morally right or wrong decision. That is called conscience, right? I'm not talking about conscience. I'm talking about consciousness. That consciousness जो है, that we do not understand really well. We consider ourselves as a conscious organism in the sense that we are aware about our surrounding. But it has something to do with our brain that we know. But what exactly in brain which allows that consciousness to emerge, we frankly do not know. That is an open question. Maybe we will have this answer. And देखो जब भी कोई चीज़ ओपन एंडेड होता है तो वहाँ पे इसीलिए आपको दिखेगा कि सब लोग वहाँ पे ओपिनियन देंगे. जैसे आप चले जाओ किसी बुक स्टॉल में, आपको एक कॉन्शियसनेस पे बुक मिल जाएगा जो कोई न्यूरो साइंटिस्ट ने भी लिखा होगा, किसी योगी ने भी लिखा होगा, किसी फिजिसिस्ट ने भी लिखा होगा, किसी फिलोसोफर ने भी लिखा होगा. तो आपको हर टाइप के मिल जाएंगे. द मोमेंट वी नो व्हाट इट इज, देन बुक्स नहीं मिलेंगी आपको. We know that what is consciousness. Anyways, but that's a very good start, that we are a conscious organism. What else? Like what makes us intelligent? That's another very good point. But even animals do that. Even animals have this understanding. So the point was that understanding or emotions, right? But I do think that what you said is very important, that understanding emotion. Now that is something which I do think is unique to human beings, in the sense that we are slave to our emotions, no matter how कितना भी आप खुद को claim कर लो कि आप बहुत ही emotionally intelligent हो, but we fundamentally are slave to our emotions. But perhaps we are the only organism which can overcome our evolutionary instinct of, let's say, fight, and we can cooperate. Let me explain that further. The most intelligent species after human being will be perhaps chimpanzee or pigs or octopuses. These are very intelligent organisms, by the way. Dolphins are quite intelligent. But even these organisms, they suffer from cooperation in a very large number. This is chimpanzee. The closest ancestor we have is chimpanzee. Not more than 2 dozen chimpanzee can cooperate together. In a pack of chimpanzee, maybe there will be 2 dozens, not more than that. But if human beings want, we can cooperate in millions. Like 2 million people can cooperate together. So we can overcome this instinct of conflict, of fight, and rather we can cooperate. Of course we fight, which tells you that we still are evolving from that animal instinct. We do fight. We have fought some of the most bloody wars. But human beings are known for cooperating in a very, very large number for whatever issue it is, right? Whatever can unite us. It can be some religious ideology, some other political ideology, or some nationalism, or anything. But it can unite people in millions. It is not at all possible in any other living organism as we know of. What else? Sorry? Okay, that's also a good point. Yes, go ahead. Sorry, IQ level. I'm talking about people, as I'm assuming that all people are intelligent, which in itself is a not very good assumption. But you are absolutely right that in terms of, and all of you are absolutely right, that in terms of the reasoning capability which human brain has, just say, again, I will go back to the chimpanzee. Chimpanzee cannot be taught complex mathematics. Chimpanzees are able to do simple mathematical calculation. You give them 2 apple, 3 apple, they will know it is 5. But they will not be able to do complex calculation. For example, they will fail at multiplication. People have experimented on that. They will fail at multiplication. So you cannot taught a chimpanzee about a daily routine. That abhi ye karna hai, fir ye karna hai, fir ye karna hai. But you can teach that even to a kid, a toddler of like 5 years old, that ye hamara pura daily routine hoga. So there are a lot of differences, like in terms of how much information human brain can grasp. And it's quite, one of the fundamental reason here is that given our body size, our brain is actually quite huge. जो हमारा बॉडी साइज के हिसाब से जो ब्रेन है वो ज़्यादा बड़ा है, बहुत बड़ा है। जैसे एलिफेंट का ब्रेन जो है करीब 2 टाइम्स ज़्यादा बड़ा है ह्यूमन बींग्स के कंपैरिजन में, बट उनका बॉडी इज लाइक मेनी मेनी टाइम्स बिगर दैन ह्यूमन ब्रेन. सो brain is involved into lot of other things, survival thing, how to survive. We figured out the survival part quite early, that we basically need food, water, some suitable climate. We figured out that survival part that allowed our brain to utilize its capacity for other things, like knowing about nature, understanding about your surrounding, trying to solve problems which can be useful, which can increase your chance of survival. So all of those things. Even language, by the way, has played a very important role. So I think language also is an act of intelligence. No matter what cartoon movies tell you, animals have a very limited vocabulary. Like animals cannot speak a lot of words, or they cannot express complex words, or they cannot form a complete sentence. Animals use very simple words, simple way to express their whatever they want to express to the surrounding organism. But human beings can express complex emotions into words. In fact, we can think in abstract, which is only possible, I guess, in human beings. I don't know if nobody knows if other animals are capable of or not. But think about it. Just the very last topic I talked about, quantum mechanics. Quantum mechanics essentially is abstract mathematics. That even though we are not able to imagine it, so fine. We will do abstract mathematics and we will try to predict how nature works at very smaller scale. So the amount of information human brain can store and process is just remarkable. Human brain is a very, very powerful supercomputer. A supercomputer which occupies very less space, by the way, all the time needs cooling. The same way supercomputers need cooling, human brain also needs cooling. That is why 70% of us is water, connected with billions of neuron cells. All of those neuron cells firing each other, sending information to brain. And brain can now process various type of data to look at things, listen to things, feeling of touch, all of those things. And it can do all of those things together simultaneously. So it's a very powerful computing device we have, which makes us intelligent compared to other living organisms. So intelligence is not one thing, it is very smaller things, like even the act of speaking, an act of expressing yourself into complex words, forming complex sentences, that is also an act of intelligence. It essentially boils down to how much data a particular brain can handle or can process, or how many different type of data it can handle or process. That is also very important. How many different type of data, because think of the same way computers are connected with sensors, human brain is connected with sensors. That you have eyes as a sensor which are sensing photons. All around me there are photons, and these eyes allow me to sense those photons, and that allows me to look at things. Ear is a sensor which can sense the vibration of air, and it allows me to listen to sound, right? Skin is a sensor, it allows different type of sensation. We can understand and appreciate different type of sensation. So human brain is a very, very powerful supercomputer. When we use the word artificial intelligence, essentially we mean that we are trying to replicate at least some of that aspect of intelligence, hopefully all of that aspect of intelligence. I'm not sure if it is hopefully a good thing or not. That's a separate question, I will answer that. But when I use the word AI, it essentially means that we are trying to develop a machine which can understand human, or which can, by the way, solve problems, understand problem the same way human brain does. It does not have to do all of the things human brain is capable of. But even if it is capable of doing one thing which human brain is capable of, that we can use the word artificial intelligence for it. So AI has a very simple meaning. We are talking about mimicking human-like intelligence. I will repeat, not all aspect of intelligence, but even some aspect of intelligence which will be enough to qualify a particular machine, a particular algorithm as an AI. I'm going to elaborate upon it further, but पहले आप ये लिख सकते हो, give this heading, artificial intelligence. It refers to there is a very good thing, there is a very good statement here. Honeybees are also united, by the way. But that is also quite amazing about honeybees. Honeybees act as a colony. Human beings, despite the fact that we can cooperate together, people have this individual consciousness or individual identity which plays a very important role. Honey bees का जो behavior है वो बिल्कुल group behavior है. उनका जो individual behavior है वो इतना कम है कि आप उसको neglect कर सकते हो. When honey bees go and occupy a particular place, they go and occupy that as a group, not as an individual. Human beings, yes, we can cooperate in group, but we still maintain or we still do not lose that individual identity. The moment you start losing that, that becomes problem. Again, I'm now going into domain of political science or what type of, that is a mob behavior. जो हम word use करते हैं ना, जो mob behavior वाला जो है, that you have lost your own morality because there is a mob mentality of lot of people. So that is where you actually lose your intelligence. But one of the fundamental difference is, ऐसे तो bacteria देखो, there are like millions and billions of bacteria which decompose the food. But as far as we know, there is no concept of consciousness in bacteria. They do not have some functional brain. They only know how to multiply, and that too, they only know unicellular organisms which can keep multiplying, keep increasing their number. That is their purpose. That is what they do. So human being का जो बहुत fundamental difference है honey bees के मुकाबले बाकी मुकाबले, there are other things. Although honey bees are actually quite intelligent species, I should tell you this, that as an individual honeybee, they have very good understanding about sun, position of sun in the sky. They have very good understanding of time of the day, and they have very good understanding of directions also. जैसे यूपीएससी ने पिछले साल एक क्वेश्चन पूछा था, and which was covered by the way in lot of documentaries about honeybees, that honeybees को अगर आप बहुत बार देखोगे, like people have actually observed them closely, and when they often they found that they go out from wherever they have first occupied an area, they go out, they come back. But when they come back, then scientists noticed that they start waggling a lot. उनका जो tail है, they take that tail and they start dancing a lot with that tail in very specific direction. And then they figured out that with that tail, they were actually telling you that what is the next place where we should occupy. That place has a lot of information, lot of resources available. And they use sun as a reference point. So sun is one line, and compared to sun in whatever direction their tail is denoting, that tells you the direction where something is located. And the more they waggle, it means the farther it is. If they are waggling less and less, it means it is closer. So this behavior, honeybees do exhibit intelligent behavior. Ants exhibit intelligent behavior, that is also correct. Ants can cultivate fungi. जैसे हम cultivation करते हैं, ants cultivate fungi. That is an intelligent behavior. Orangutans. Recently there was a news here that there was an orangutan which was injured on the face, and it then went to find a medicine, a plant-based medicine, rubbed on it and became cured. That is an act of intelligence, by the way. Octopuses, send them to a puzzle, a complex puzzle, and they will find their way out. So a lot of species do exhibit intelligent behavior. Dolphins come together and they make a plan that how to do the hunt. जैसे ancient human beings जो हैं, how they used to act as a hunter and gatherer, dolphins do that. They come together and they make, dolphins get high, by the way. There are certain substances which have psychogenic properties, and like ganja, something like that. And dolphins basically get high on that. So I don't know if it is an act of intelligence, but you get the idea. So a lot of species do exhibit act of intelligence, but the extent of human brain, that is just unmatched. इसमें कोई doubt नहीं है. Write down few more things. सब कुछ भी नहीं लिखा हमने. Artificial intelligence refers to simulation of human intelligence. Simulation of human intelligence in machines programmed to think, in machines programmed to think, reason, learn and make decisions. Reason, learn and make decisions. It aims to create systems It aims to create systems that can perform tasks which would ordinarily require human cognition, which would ordinarily require human cognition, human cognition. This is the definition part. AI का जो development है, that is happening into many stages. जो भी stages हैं, they are divided mainly into two categories. There can be further subcategories, but जितना भी AI है, it can be divided into two categories. The first is called narrow AI or weak AI. आप लिख सकते हो? AI can be divided into narrow AI. This is also called weak AI. Just write down a line here. Systems designed and trained for a specific task. Systems designed and trained for a specific task or group of tasks जितना भी AI अभी हम यूज करते हैं, all of that including ChatGPT is an example of narrow AI. The second category is called general AI or strong AI. Strong AI. It seeks to create machines. Machines that possess the ability to understand, learn and apply knowledge across different domains, has emotional understanding, and also consciousness. Aware about your existence, your role, about your surrounding. Write down a line here. As of now, general AI is largely theoretical and does not exist yet. All of the movies where you have watched, where a machine has become rogue and machine is trying to destroy humanity, that will be example of general AI doing that. We haven't developed general AI. Maybe by end of this decade, OpenAI is claiming that they're very close to it. OpenAI is a company. अभी Microsoft सबसे बड़ा stakeholder है उनका. OpenAI, the company which is behind ChatGPT and all. So they have actually claimed that they are experimenting upon it, and they have not given a timeline. Maybe it will take some time, maybe some more time, that they can claim that we have developed a conscious machine. Sophia is a very specific type of AI where certain responses it can create based on the type of data set which has been trained. Just because there is a AI which has a human face, or it looks like a human, does not mean that it becomes a general AI. Right? So a lot of robotic assistants are available nowadays, but none of them are example of general AI. ये बहुत clear होना चाहिए that it is not the presence, not the body, it is our mind which makes us this very unique. The consciousness that emerges from our brain. So it's not, even if you somehow could preserve this consciousness into a machine, then you could preserve all of my memory and all of my capability rather than this entire organism, other part of the organism. So Sophia is a robot, an AI robot, which does have some of the technologies and tools of AI, but it will not be an example of general AI. So general AI as of now is largely theoretical. Maybe in few years, even general AI will be a possibility. That's a very like unknown domain. A conscious AI, that is in fact, जब भी हम ये बातें करते हैं, the reason I talked about all of the movies you have watched, because a lot of people warn against general AI. They feel that, think of a superior being. Think of how, as a superior being, how we have behaved with other organisms. We are intelligent, we are superior in sense of that we have more thinking capability, but because of how we have behaved with other organisms, and because of our behavior, many organisms on the verge of extinction. So a lot of scientists fear this, that a conscious AI which somehow becomes, let's say, enemy of humanity, and what it can lead to. So that's a like challenge perhaps for future, or not that far future, or if it is a challenge, we need to figure something out about that. But even without that, there are a lot of other challenges which we should be aware about. So आपका जो क्वेश्चन है कि what are the like possibilities तो बहुत सारे हैं अगर हम benefits की बात करें, but it can also lead to a situation where an AI has become rogue, an AI which has become independent and has decided that it does not now bound itself, or does not think that human welfare is the most important thing as part of its programming. An AI which has been able to redesign itself and has created a version where it does not think that human welfare is part of its programming. Is that possible? Why not? If we are talking about a conscious AI, then yes, it is a possibility. A lot of people, Dr. Stephen Hawking, late Dr. Stephen Hawking, he warned against it. Elon Musk keeps talking about this, that general AI का जो pursuit है, that may not be a very good thing. So a lot of people have warned against it, but even वो तो चलो, again I will repeat, वो future का concern है, but अभी भी बहुत सारे concerns हैं which we should be aware about. Humanoid robot cannot be considered general AI. I will repeat, it is not the human-like presence which makes us a conscious organism. It is fundamentally our brain. It has something to do with our brain which makes us a conscious organism. And as of now, general AI remains largely theoretical. Let's take a break here. After that, we'll talk about technologies of AI. So when I use the word AI, it is not one technology, but multiple technologies which are powering artificial intelligence. Give the saying technologies of AI. First is machine learning. Making an intelligent machine is not a new thing. Human beings have been trying to do that for last 40, 50 years now. A lot of development happened in 1990s, where based on logic, people developed machines, but logic is flawed. Machine learning essentially is a type of algorithm. If I have to explain machine learning in very simpler terms, even though the concept in itself is very complex, machine learning is simply a type of algorithm. So think of a typical computer algorithm. Algorithm essentially is a set of instructions which you have programmed, and those set of instructions can execute a problem, solve a problem. You have given them some input and they give you output. जैसे when you learn to multiply two numbers, you followed a set of instruction कि आपने simple multiplication, आपने table पहले याद करा, and उस table के basis पे now you have to multiply, let's say 25 into 42. And you were taught set of instructions, you knew the logic behind that instruction, step by step, how do you multiply and get the correct number. So think of an algorithm where you simply have designed a computer program, that how you can program that in set of instructions, and a computer can execute that program based on whatever input you have given. Any two number you have given, and it can give you multiplication, it can multiply and give you the output. But you have designed that instruction. If it is 2 into 5, it's very easy. But if it is a very large number, you have to multiply, it is going to take some time. You'll have to spend some time. So what you did here is that you designed a computer algorithm. A computer is running that. Basically, जो electrons हैं, जो transistors हैं, they are executing your program. Now they are following instructions programmed by you, but they will be able to follow those instructions really, really fast compared to what you can do. And that is why they can multiply two very large numbers in a very small time. But जो fundamental point अभी भी यही है कि instructions आपने design किए थे, वो instructions आपने लिखे थे, algorithm आपने design किया था. Machine learning algorithm is very different from a typical computer algorithm. Machine learning algorithm evolves based on the data you have trained itself, the data on which it has been trained upon. So machine learning algorithm का जो output है और जो set of instructions हैं, ये आप design तो करोगे, but those set of instructions, by the way, AI can design its own machine learning algorithm in future. AI is already becoming really good at coding. But think of a machine learning algorithm as that the more data you train a typical machine learning algorithm, the better its response becomes. It's like a toddler learning to walk. That think of a toddler, small baby, trying to walk, is going to fall down a lot. But with more and more practice, finally the baby is going to learn to walk. So think of a lot of mobile phones, a lot of cameras nowadays, a lot of apps, that when you use these apps, they try to tell you that how old are you or what is your gender. बहुत सारे ऐसे हैं ना? So there is a very good chance that they will make a lot of mistakes, but think of them as a machine learning algorithm. They have been trained on many pictures of human beings that at different stages, what human beings look like, how can we distinguish, even on facial parameters, how can we distinguish between a man and a woman, all of that. And the more data you train the system, the more amount of data you train the system upon, it becomes better and better at following those instructions. And when you finally, after let's say millions of pictures you have trained upon this machine learning algorithm, and you give a random picture to it, and it is trying to determine that age of the person or the gender of the person. Lot of algorithms try to predict what you look like, let's say 10 years down the line. And that is again based on the data. The best example I can think of that how tech companies use all those hashtags to collect data. अभी आज से 3-4 साल पहले on both Twitter, Instagram, Facebook, on all of these platforms, there was a challenge which was very popular, hashtag 10 year. I don't know if you participated in it or not, that what you looked 10 years ago and what you look like right now. Now everybody thought of that as a very like nice challenge. Let's see that how we have transformed. But that essentially is a data set for tech companies that Facebook will collect that data, Google will collect that data, and will use that data to train its machine learning algorithm that how people look like when they age by 5 years or 10 years or by 20 years. तो जितना ज़्यादा डेटा पे वो ट्रेन करेंगे अपने सिस्टम को, उसका जो आउटपुट है उतना बेटर होते चले जाएगा. So machine learning algorithm fundamentally is different from a typical algorithm, that its output becomes better and better as it is trained on more and more amount of data. आप लिख सकते हो? It is a subset of AI. It is a subset of AI that provides systems with the ability to automatically learn from data and improve with experience. To automatically learn from data and improve with experience. Improve with experience. So essentially, machine learning algorithm will be a very, very different algorithm compared to a typical computer algorithm, where based on input, following set of instructions, a computer program giving you an output. Here, again, based on input, but now this program, this algorithm has been trained on more and more amount of data. And जितना ज़्यादा data पे आप इसको train करोगे, it is going to become better and better at giving you output and correct output. So it is very different from a typical algorithm. Within machine learning, there is a concept called deep learning algorithm or deep learning. Deep learning. Right on, it is a subset of machine learning. It is a subset of machine learning. Machine learning. That mimics the neural networks of human brain. That mimics the neural networks of human brain. Neural networks of human brain to process data and create patterns for decision making. To process data and create patterns for decision making. Before I explain this further, I have a simple question. What does this word neural network of human brain, what does that mean? Anyone who can simply explain this? एक वर्ड हमने लिखा है यहाँ पे, neural networks of human brain. इसका क्या meaning है? Essentially talking about neurons here. Our body has many type of systems. We talk about digestive systems, respiratory systems, all of those systems. You also have neurosystem. Our body, brain directly is connected to the spinal cord, which is connected to the rest of the neurons in our body. And whatever happens in any part of the body, our brain immediately knows about that. For example, let's say hot water pours down here, and I immediately know what to do. I immediately feel this hotness and I know what to do about it. So there are skin as a sensor that measures this sensation, and then there are lot of, this entire neural system is responsible for it. That one neuron sends information to the next. Neuron is essentially a cell, a very specific type of cell. The same way you have lung cell or kidney cell, a neuron essentially also is a cell. But it has its own unique structure, and that cell has its own unique function. It is connected to this giant network of other neurons, and it starts firing. The moment it gathers, receives some information, it sends that information to the next neuron with help of electrochemical signal, either an electrical signal or chemical signal. And they travel with really, really high speed. They go to the brain, and they will, so one neuron passing information to the next, to the next, to the next. And then they create a pathway. And that pathway already is designed in a way that the part of brain which becomes activated to a particular stimuli. You are feeling happy, which part of brain will become active, versus when you are feeling sad, which part of will become brain active. So human, again, as I was talking about earlier, that जो human neural brain जो है बहुत ही powerful computing device की तरह आप इसको imagine कर सकते हो. And this powerful computer is connected with all of the sensory organisms, but those sensory organisms send information for the processing with help of this neural system which our body has. So machine learning algorithm essentially tries to mimic that. Rather than, however, sending information into electrical or chemical signal, it sends information about probability. A deep neural network will contain an input layer and an output layer. In case of human brain, you can think of that input layer as all of your sensory organisms. Output layer, what brain is telling you to do. Finally, जो आपका output होगा based on whatever sensory organisms have activated. But in between, you have all of these neural network systems, and those neural network systems keep exchanging information from one to another. So we try to design an AI where an AI is taking input and that input is being processed on all of these networks. And on this layer, when it was processed, it tried to provide output, but maybe it did not succeed. It sent whatever information, whatever processing it has done, it sent it to the next network where further processing happens, to the next network where further processing happens. And finally, the output layer, it is going to tell you the correct output with very, very high probability. Let me explain this with a simpler example. One of the great computer scientists who lived during, again, World War II, his name was Alan Turing. He was a British scientist. Alan Turing developed, he was heading basically a project called Enigma. That played a very important role. It was able to design a computer. So, जो encryption है, that we use encryption to encode our data, ऐसा नहीं है कि खाली हम अभी use कर रहे हैं, past में भी हमने use कर रहे हैं. Julius Caesar used that, like 2000 years ago, Julius Caesar tried to send letter into encrypted form so that his enemies will not know about it. So even Nazis were doing the same thing. Hitler and his army, they were doing the same thing. They were communicating with each other in encrypted message. Again, with the hope that just in case, even if somebody does get a hold of this message, they will not be able to know what that actually message contains without understanding the decryption. So Alan Turing and his team was able to design a computer which broke that encryption. And Germans, by the way, did not know about this. That Alan Turing ka jo team hai, that designed a computer that broke this encryption. And now whatever Germans are communicating, even though they're using some encryption, British intelligence agency already has this information that what is being communicated. And that played, by the way, a very important role. And since 1942 onwards, the tides of the war kept on turning. So from 1939 to 42, Germany is all blitzkrieg, destroying many parts of the world. But 1942 onwards, they are on equal footing. 1943 onwards, Germany is on the back foot. By 1944, Germany gets defeated. So this computer designed by Alan Turing actually played a remarkable role here, that it was able to break encryption of the Nazi army. And they had now all the information beforehand, that what are they talking about, what are their plans. And they did not even know that this encryption has been broken. Alan Turing in his personal life was gay, and at that point of time, being gay was a crime. We inherited that colonial legacy, by the way. आपको पॉलिटी के क्लास में और डिटेल में पढ़ाएंगे इसके बारे में. So Alan Turing, when he was arrested, when this became an information that he is gay, when he was arrested, then he was given an option that either you go to jail or you go for chemical castration. Chemical castration is use of certain medicines which suppresses your sexual urges. So Alan Turing went for the latter. But those medicines had their own side effect. It caused severe depression, and he committed suicide. So a person who, by the way, may have played a significant role in defeating Nazis died because of its sexual orientation. We are not that intelligent. However, the reason I talked about Alan Turing, that Turing also developed a test called Turing test. It's a very famous test. Without going into details of what that Turing test is, let me only explain the purpose of Turing test. मान लो that where I am standing, there is a curtain. And below this curtain, there is somebody who is answering my questions. I am asking some questions, and there is someone who is answering the question. I want to know that if that someone is a human being or is it a computer? Is it a machine or is it a human being? How do I distinguish without actually looking at that computer, without looking behind the curtain? So Alan Turing devised a method, a series of questions, which can be used to determine that even without knowing, by asking this series of questions, you can determine that you are dealing with a bot, some sort of programmed machine, or are you actually dealing with a human being. So all the tests which aim to determine that, they are called Turing test. सबसे बढ़िया एग्जाम्पल जो ट्यूरिंग टेस्ट का है वो कैप्चा फिलिंग है, राइट? आपको कभी भी आपने देखा होगा कोई भी प्रोफाइल बनाओ तो आपके एक ऑप्शन आता है कि आप कैप्चा फिल करो. कैप्चा बड़े आड़े तिरछे से लेटर नंबर्स होंगे. द लॉजिक बिहाइंड दैट कैप्चा टेस्ट हियर इज that ये जो आड़े तिरछे से letter है, a computer will not be able to make sense of it, but a human brain, even in that distorted version, will make sense of that this is A or this is 2 or this is some special character. So CAPTCHA filling, for example, can be a great example of that. Or even, by the way, that test where you have to go and click that I'm not a robot. Kara aapne? What is that test all about? That I'm not a robot. So the test there is not the clicking part. The test here is what you do before the clicking part. So a human being will not go directly. जो आप mouse कुछ भी आप use कर रहे हो, it is going to follow a random pattern. जैसे simple सा मान लो एक mouse को भी लेके जाके आपको click करना है, it is going to follow a random pattern. But a machine, because a programmed machine will go into straight line or will have bilkul fixed set of instructions which it is going to follow to click on that. So the test is not clicking on it. The test is what happens before that clicking. So even that is also a great example to distinguish that if you are dealing with some sort of programmed bot or you are dealing with an intelligent human brain. A good AI should be able to solve Turing test. A good AI should be able to correctly identify that captcha you have, which has been given to it. So think of deep learning software, that there is a distorted version of A written somewhere. And that deep learning software, it's supposed to know that this letter is A. Again, it's a very simple problem, which I am presenting here. That first layer will try to divide this into many parts, will try to process whatever information it has gathered about this image. It will try to process this information and it will try some probability that maybe it is A with 15% probability, maybe it is W, maybe it is M, maybe it is X. And it is going to assign all of that probability to all of the possible output. And then it is going to send that information to the next layer. On that next layer, further processing will happen, which will maximize the probability of A, because this entire deep learning software has been trained on a huge amount of data set, millions of different versions of A, and they do know what A looks like even in distorted version. So on all these layers, processing keeps on happening, and finally the output layer gives you that maybe it is A with 99.9% probability, and that will be the answer also given by this particular software. What if it identified this as a W? Doesn't matter, because it doesn't matter in the sense that yes, it has made an error, but that error now has become a data. It has become a training data. Now when it looks at this A, it is not going to make the same mistake. So deep learning software is a subset of machine learning. However, in this design, machine learning is a larger term, can deploy various type of techniques. But deep learning deploy this technique that let's use these neural networks. And all of these neural networks, by the way, are connected. And all of these neural networks, data is being processed so that our system becomes better and better at giving you the correct output based on whatever input has been given to it. This deep learning software, even in 2016, it was so powerful, I'm talking about 8 years ago, that in almost all strategy games, a deep learning software cannot be defeated by human beings. The most famous game here is that black and white dots se game khelte. What is it called? Checker, right? Google developed I don't know what it is called. I'm assuming that you were correct. So Google developed a deep learning software here. I'm forgetting the name of the deep learning software. I don't think it was Deep Loop. It was something else. But it was able to defeat any human being, the best players of that game. As of now, a well-trained deep learning software will easily emerge victorious even against Magnus Carlsen in chess, in a game of chess. Because think about a good chess player, what it does. A good chess player will try to anticipate the moves of the opponent, that how an opponent is going to move maybe 2, 3, 4 steps, 5 steps ahead. And they have all of this plan going on in their brain that accordingly what will be the best thing. And they can do that like few steps ahead of you. And that is how a good chess player will be able to defeat the opponent. Of course, they will keep changing their strategy. It will be a dynamic strategy that depending upon some unknown move, they will keep changing that strategy. So a deep learning software can do, again, it can calculate the probability of all of the cases where a deep learning software is winning, maybe 100 steps ahead. And you cannot defeat a deep learning software. The best you can hope for is a draw. And that is exactly what we are right now. This is the condition that in any type of strategy games where human brain is applied, a deep learning software will either win or will end into a draw. It is not going to lose, or hardly it will lose. Like, it will be a very rare thing for a deep learning software to lose. So deep learning has been now used to solve really, really complex problem. In the previous class, I have talked about that protein folding problem, that amino acid structure has been given and you have to predict what is the final structure of protein. A deep learning software, before that human beings used to do that, and the percentage of accuracy was 30 to 40%. As of now, the percentage of accuracy is 90 to 99%. And some teams started developing deep learning software. One of the most remarkable news I came across was last year in September or October, that some museum who had recovered some Roman manuscripts, 2000 years old. But those manuscripts had burned significantly. And because of that, a lot of words were not very visible, or it did not mean exactly that what people wrote there. And they announced a prize, some $100,000 prize, that whoever can decipher it will get that. And few teams, they collected all of the various type of scripts connected to Roman script, designed a deep learning software, trained upon various type of data set, and they deciphered that. Right, and the reason why I felt it to be very important, because I felt that something like this perhaps can be done for Indus Valley civilization. So in ancient India, we'll be taught about Indus Valley civilization, and people of Indus Valley civilization, they knew writing. They have left that writing. The only problem is we do not know what they wrote, because the script they used, that script as of now has not been deciphered. So I really do hope that maybe somebody will develop some AI tool and will be able to decipher the Indus script. So in remarkable ways, people are using deep learning software. In different domains, people are using deep learning software. It aims to mimic the working of human brain. Yes, Alan Turing पे बहुत बढ़िया movie है, Imitation Game. You can watch that movie. The next is, give this heading, computer vision. Computer vision. Write down just in one line here. It enables machine to interpret. It enables machine to interpret. AlphaGo, thanks a lot. The name of that project, Google का जो मैं बात कर रहा था, that project DeepMind, जो है AlphaGo is a computer program developed by DeepMind. DeepMind was the Google's deep learning software that was able to develop a program called AlphaGo, and that AlphaGo became better at playing that board game. Checkers, which I was talking about earlier. I hope you are right. So anyways, write down few things here about computer vision. This enables machines to interpret and make decisions based on visual data from the world. Based on visual data from the world. This can be used in image recognition. This can be used in image recognition, facial recognition, self-driving cars, among others. So think of a software. The earlier example I gave you, that some sort of software which, by getting some image as an input, it is trying to determine the age or gender, or even perhaps what this person will look like 10 years down the line. All of that will be example of computer vision. Or think of a self-driving car equipped with deep learning software, which not only looks at the surrounding, let's say with help of LiDAR, light detection and ranging, but is also able to distinguish between these objects. That this is a traffic signal, this is a person, and we see them as different things. The deep learning software will see them into those zeros and ones, but even it will be able to distinguish between those zeros and ones, that it is a cat or it is a human being or it is a traffic signal, and based on that it can execute decision. Deep learning software is being used in really interesting ways. I was talking to one of my friend who works for an insurance company in Bengaluru and who works for a data company, like a tech company, and that tech company is working for an insurance company based out of America. अब इंडिया में जैसे मान लो कार इंश्योरेंस आपका लेना है, तो सिंपल से प्लान्स हैं, आपका कार कितना पुराना है, इस बात पे बिल्कुल डिपेंड नहीं करता है कि आप कैसे ड्राइवर हो. इस बात से सीधे सीधे आपका कार 5 साल पुराना है, दिस विल बी द इंश्योरेंस पॉलिसी, 3 साल पुराना है, दिस विल बी द इंश्योरेंस पॉलिसी. But in America, insurance companies take these things, they have taken these things like up a notch. What they're doing, that in the car itself, you have a camera. That camera is actually monitoring your movement as a driver. And if you're a rash driver, then the insurance policy designed by that insurance company will be much, much more costlier. Versus if you are a safe driver, take all of the safety measure, does not change lane a lot, all of those things, then the insurance policy will you be much, much more cheaper. So not just about car, but also about the driver. And based on that, there can be different type of insurance policy. So people are using computer vision in different ways. I love football a lot. I came across a news that one of the matches, a camera was used to track the movement of the football. How that football is moving. It was automatically moving with the movement of football. So that because how we see that around that ball, how formation of the two teams are changing. Although it caused an error, it identified the bald head of referee as the football, and then it was just monitoring that bald head. So yes, even AI can make a mistake, but it will not make the same mistake next time. So AI will learn from its own mistake based on the visual data which it is receiving. The next is natural language processing. भाई ये जो कंप्यूटर विजन का एक नेशनल सिक्योरिटी में भी एप्लीकेशन हो सकता है. आपने फिल्मों या टीवी शो में देखा होगा दैट कोई टेररिस्ट का स्केच है, रिलीज हुआ है, इमेज रिलीज हुआ है, एंड देन वी आर ट्राइंग टू मैच दिस इमेज विथ लेट्स से सम सीसीटीवी कैमरा डेटा दैट आपके पास कंटिन्यूसली लाइव स्ट्रीम डेटा है, एंड यू आर ट्राइंग टू प्रिडिक्ट द मूवमेंट ऑफ अ पर्टिकुलर क्रिमिनल, सम पर्टिकुलर टेररिस्ट विथ हेल्प ऑफ कंप्यूटर विजन. सो जितने भी पावरफुल इंटेलिजेंस एजेंसीज हैं, दे विल हैव सच टेक्नोलॉजीज एट देयर डिस्पोजल. इसका एक क्रिटिसिज्म ये भी आता है, अभी हम क्रिटिसिज्म हमने डिस्कस शुरू नहीं करा है, दैट एआई के जो चैलेंजेस हैं, दैट इट कैन ऑल्सो बी यूज्ड फॉर मास सर्वेलेंस इन जनरल रादर दैन being used for national security. It can simply be used to monitor citizens by some authoritarian government, and it, by the way, already is being done. China is the best example here, that China is using computer vision again at a different level. Write down a few things here. In natural language processing, the ability of a machine to understand, interpret, and generate human language in a way that is valuable. Machine to understand, interpret, and generate human language in a way that is valuable. इसका जो simplest example है, all of these assistants which we are using in our mobile phone, that Siri or OK Google or Alexa, even as a device, Amazon Alexa, all of these are example of simple natural language processing. But इसी का जो advanced version है, that is called large language models, and large language model is behind that ChatGPT which we talk about. But ChatGPT fits into another domain of AI which we call generative AI. So not technologies of AI, but give the next heading generative AI. चैट जीपीटी का फुल फॉर्म क्या है यहाँ पे? Okay, so the full form here is this as a tool has been developed by this company called OpenAI. OpenAI as of now, जो सबसे important advancements AI में जो हो रहे हैं, that is being done by OpenAI, and Google is also not far behind. जैसे Google का जो generative AI खुद का tool है, Bard is outdated, now it has been renamed as Gemini. So चैट जीपीटी का जो कुछ वर्जन है, जो ओरिजिनल वर्जन था, उन्होंने पब्लिक के लिए पहले नहीं करा था यूज. They limited the use of earlier version of chat GPT. But after GPT-3, third version, they announced 3.5. And that GPT 3.5, which we call chat GPT, that is available for all of us. And that is available totally free of cost. So that is why in the very first class, I asked you to use chat GPT as much as possible to understand not just science and tech, but it can be helpful in many other topics. Chat GPT can be a great resource in your UPSC preparation. But इस word का meaning क्या है? Generative pre-trained transformer. It is generative in the sense that it can generate data. You have a respond, you ask a question from it. That is your input, right? And based on that input, it is going to give you some response. But that response, so because it is giving you an output, it is generating data. जैसे go to ChatGPT, ask that explain the technology behind ChatGPT. That is your question. Based on that question, ChatGPT is going to generate an answer. So hence the word generative. Pre-trained, that it has been trained on huge data set, almost entire knowledge which is available on internet. Many research journals, which often are not available. They may have some based on some आपको prescribe करना पड़े, and all of those subscribe करना पड़े, sorry, subscribe करना पड़े, and all I was in my mind I was thinking that prescribe does not look correct. Anyway, so जो आपको subscribe करना पड़े, बहुत सारे जो books हैं that you have trained an AI system on many research journals, on entire Wikipedia, or on entire every knowledge available which is on the internet, all the books which are available out there. So that is the meaning of the word pre-trained. And then whatever it has learned from that training data, it can transform, it can extract meaningful things out of that training data, and it can generate based on your response. That is the meaning of the word generative pre-trained transformer. That it can generate text or image or video. By the way, ChatGPT can only do that for text, but OpenAI का एक और tool है, which is called DALL-E. And DALL-E can generate image also. Just type on DALL-E that I want a picture of dolphin flying in space on some spacecraft, and it will be able to do that. It will take hardly like 50 to 60 seconds to do that. So it can generate an image based on your response. आपने text आपने कुछ करा, and it can generate an image. That is also an example of generative AI. और OpenAI का जो सबसे advanced tool है, which is not available to public as of now, that is called Sora. Sora they have only announced, or they allowed it to use for very limited number of users. And Sora can now actually convert text into video. That आपने text आपने कुछ type करा, that again I want something dolphin now flying in the ocean, not in the space. But no longer you want an image, you actually want a video of it. And Sora will be able to do that. Because Sora has been trained on perhaps all of the YouTube videos which are publicly available, or even some of the lot of other video streaming sites जहाँ पे you have to pay money, Vimeo और जो भी video streaming sites हैं, and all the movies and all whatever is available, all the cassettes, and it has been trained on all of that data set, and it can extract meaningful information from all of that based on your response, and it can generate a new video for you. So wherever we are generating text, images, even codes, by the way, AI is becoming really good at coding. Simple coding के लिए, that is why आपने सुना होगा कि बहुत सारी जो IT companies है, they are firing people. Simple coding के लिए you do not need people to hire. You can simply design an AI and that AI will do the coding part. Right? So if you want to actually become good at technology, then you should learn large language models, you should learn machine learning, you should learn AI. And yes, then you will have utility into tech sector. Otherwise, and even by the way, in future, even for that, perhaps utility will be very limited. Lot of work is simply being done by AI systems here. So generative AI simply means that we are talking about an AI system which can generate text, images, or even videos based on a user response. आप लिख सकते हो? A type of AI that can generate new data, similar to data it has been trained upon, which can include text, images, codes, or even videos, Example आप लिख सकते हो, ChatGPT developed by OpenAI, DALL-E, again developed by OpenAI, DALL-E, Sora. So ChatGPT, DALL-E, Sora. Sora is, it can convert text to video. ChatGPT, text to text, DALL-E, text to image, Sora, text to video. ये जो तीनों हैं, they have been developed by OpenAI. But you can definitely write Gemini. Gemini के भी बहुत सारे वर्जन हैं. तो Gemini का बेसिक वर्जन है, that is again available free of cost to all of users of Google. But Gemini जो advanced version है, that is based on subscription. Similarly जो GPT, ChatGPT का जो advanced version है, so GPT 3.5 is available free of cost, but GPT 4, DALL-E, that is based on subscription. Sora is not available for public as of now. Sora is under development. They allowed few people to use Sora, and they published on their Twitter platform, on the social media platform, that what it can do. But Sora is not available for public. ChatGPT recently went an upgrade. GPT-4 has went an upgrade, and they're calling it GPT-4o, Omni, O for Omni. They're calling this AI called Omni. And that Omni is now very good at doing a lot of things. तो अभी तक ChatGPT में ये था कि आपने text पे पूछा और it responded to it. Omni can look at the surrounding, and based on that surrounding, if you want to, for example, you simply can ask a question on Omni, allow it the video access of the surrounding, and it will tell you what that surrounding is. You have a mathematics ka problem, show it the mathematics ka problem, and it can answer that problem. It can explain that solution in simpler words. So, and this was announced by OpenAI just a week ago. जो Omni AI है, that was announced just last week. So there is a rapid revolution going on in the field of AI right now, particularly in the field of generative AI. But और भी बहुत सारे tools हैं. जैसे there is a, आपने deep fake पढ़ा होगा. Deep fake क्या होता है? एक जो सबसे सिंपल यूज केस डीप फेक का होगा कि आपने फेस स्वैप करा, बॉडी स्वैप करा of two people. That will be one of the simplest application. But even deep fake simply can mean that generating an image of somebody which is simply a fake image. Nothing happened like that, and you are using some tool like DALL-E or something else. But yes, it can also involve swapping bodies of two people. Just this was a huge news few months ago. one of the actresses, Rashmika Mandana, she complained of this deep fake, and then a lot of other celebrities came out that how deep fake is being used. So हाँ, अभी जो पूरा है होम मिनिस्टर को लेके जो केस चल रहा है, that is some person in Andhra Pradesh used deep fake images. So deep fake जो है, that can use lot of technology. One of that technology is called generative adversarial network. There is a technology called variational autoencoder. Do not worry about these dangerous names. In terms of approach, that how they actually aim to generate an image, this is generative adversarial network. This will be very helpful in generating images. In terms of how it does, that can be understood in simple word. Imagine that you have a friend. Your friend is really, really good at making drawings of people. That बहुत ही बढ़िया drawer, बहुत बढ़िया drawing करता है, and it can make very realistic drawing of people. आप नहीं कर सकते हो, आपके पास एक capability नहीं है, but आप उसके friend हो और आप बहुत बढ़िया critic हो, right? Friend को ऐसे भी आप criticize करते हो, तो आप बहुत बढ़िया critic हो. And as a critic, what you will do? You will tell your friend that ये जो feature है realistic नहीं है, made up लग रहा है. This looks like that somebody has drawn it. Your friend is trying to, let's say, draw a picture which will look like as it is clicked by a camera. There are people who can do that. So let's say that that person is using some critique. That critique will tell that person that अभी भी कुछ flaws रहते हैं, इसको ठीक करो. And critique अगर ज़्यादा better है to point out flaws, then critique should be rewarded. But जो artist है वो अगर better है, that critique is not able to point out flaw, then artist will be rewarded. So generative adversarial network, it essentially includes two neural network. One of the neural network is creator, another is called discriminator. So by the way, I generated this image which I showed in the previous class using DALL-E. So this is not an image I have downloaded it from internet. To explain free space optical communication, I simply had a very simple response on DALL-E that I want an image explaining free space optical communication. That it was a very simple response, and this was the image which was generated. I did the same thing for Li-Fi, that I want a simple image explaining Li-Fi, light fidelity as an infrastructure, and this was the result. And by the way, this was a very simple input. I could have made it more complex, more specific, and based on training data, it would have been improved. It would have been able to improve its performance. So anyways, generative adversarial network here means that there is a generator. That generator generates images based on response, but there is a discriminator. That discriminator has access to all of the real images, and discriminator is telling generator that what are the fault. And at a point of time where discriminator cannot distinguish between real and that generated image, that is where this particular software will become really, really good. So they both will be rewarded based on who is coming out on the top. If generator is generating an image, discriminator cannot find anything wrong with it. Versus generator is generating an image, but discriminator can find a lot of things wrong with it. But based on that, generator generates another image. So people have been using such type of neural network technology to generate images. This is one of the fundamental technology behind deep fakes. And such technologies are now being used. There is one more technology, by the way, variational autoencoder. To explain this, how does variational autoencoder works? Think of some of the fusion dishes. जैसे इंडिया के फूड की हम बात करते हैं. इंडिया में फूड का जो पूरा वैरायटी है बहुत ही डाइवर्स है, राइट? मतलब आपको एक स्टेट से दूसरे स्टेट भी जाने की जरूरत नहीं है. विद इन अ स्टेट, गो टू कर्नाटका, साउथ कर्नाटका का जो फूड है नॉर्थ कर्नाटका से बहुत अलग है, राइट? इवन इन महाराष्ट्र you'll find that Konkani food is very different compared to other part of Maharashtra. So you'll find a lot of differences. Kutch mein jo food hai, that is very different from Kathiawar in Gujarat. So even within a state, you can find a lot of differences. Think of a very talented chef, and a talented chef which knows the secret ingredients behind all of those types of fruit. And based on those secret ingredients, a talented chef can now make a new dish, but that new dish has collected ingredients from all of those different type of food. A lot of restaurants work on this idea. A lot of restaurants, they represent themselves, or they market themselves that they create fusion dish, that they have made something from one part, something from another part, and they have used both of that dish together. So think of a very famous chef doing something like this, that is trying to create a fusion dish based on the best of some of the dishes available in India. A lot of people are like having watery mouth अभी हो रखा है इतना सारा dish के बारे में सोच के. So जो variational auto encoder है, it's like that. The think of an AI system which has been trained on many type of images. Maybe those images are not that good, or some parts are good, other parts are not good. But based on all of that data, it can take the best of all of that. And when you then ask a query from it, it is going to give you an image, but that image will be juxtaposition of lot of various data which it has been trained upon. This is what this technology is. Again, this is one of the technology behind that deepfake, that you go and use to generate an image of a tiger using variation autoencoder. The reason I'm telling you, last year I came across a news, a person won the best picture of wildlife, and then later he claimed that he never took that picture. That was an AI generated image. So the things have become so good that now an AI generated image versus a real image, you cannot distinguish between them with simply naked eyes. You will require special tools to determine that. So within AI, there are various types of developments which are happening. And I do think that even knowing these words can be more than enough for prelims or mains question. We particularly should know about generative AI and the capability which are right now available to people. Give the heading, applications of AI. Applications of AI. In any area you think of, AI has applications. How we are thinking of education or healthcare or agriculture, all of those things. Even in agriculture, for example, हम बात करते हैं प्रिसीजन एग्रीकल्चर की, कि अभी हमारा एग्रीकल्चर में इंटरवेंशन क्या होगा. तो मान लो आपका क्रॉप ठीक नहीं है, जो भी है, यू हैव टू यूज फर्टिलाइजर पेस्टिसाइड, आप पूरे के पूरे फील्ड पे यूज करोगे एक साथ. आपको स्प्रे करना है, वाटर आपको इरिगेट करना है, पूरे के पूरे फील्ड को इरिगेट करोगे. But when I use the word precision agriculture, it essentially means that based on plants' health and requirement, you are able to precisely make changes to that particular crop. People are using AI for that. Think of how we cannot distinguish between two type of same plant. आप किसी paddy field में गए, paddy field में आपके पास कुछ group of paddy at one place, another group of paddy at another place. For you, both of them are identical. They both are growing same perhaps, unless there is some remarkable major change which you can witness. But a computer vision, an AI equipped with powerful camera, can take snapshot of both of those and can find minute differences. And maybe even few strands are becoming, let's say for example, becoming pale yellow, not very like, ऐसे नहीं कि बहुत yellow बहुत मान लो on the face हो. But our eyes are not able to distinguish that. But a computer vision camera is able to distinguish that. And think of that if we program that in an IoT system, Internet of Things system, some sort of irrigation system, that it only irrigates that part of the crop, does not irrigate or only applies fertilizer or pesticide to that particular crop, does not do anything to rest of the crop. So we can reduce our input and we can make our agriculture much, much more productive because our interventions are more precise. So people are using AI in multiple ways. Think of in education that lot of papers, lot of question setting वगैरह जो है, that is done by AI now. Even in solution, checking answers, particularly in objective question, we use computer vision. That कोई manually बैठ के check नहीं कर रहा है. All of those things are being done by some sort of AI tool. And AI perhaps can analyze data in a better way and can tell us better input in terms of what type of intervention a student requires. जैसे मान लो मैंने conduct करा कोई paper यहाँ पे and कोई quiz करा मैंने, and looking at the response I am trying to figure out that which are the areas where I can perhaps spend more time. And AI can do that better than me. So that is how an AI can revolutionize even education. An AI can revolutionize healthcare. An AI system which is helping in developing a new medicine. An AI system which can diagnose diseases, by the way. And this is a personal example. I remember few months ago, one of my very close friends, my school friends, told me about his mother is ailing from some disease. And he had some basic MRI scans and PET scans. And I was able to simply upload that on AI and it gave the correct diagnosis. And now finally doctors have given the diagnosis that what she's suffering from, but it gave the correct diagnosis. And ye to chalo fir bhi aisa the disease was, which was very popular, it was easy to guess. But I came across a news where a woman who suffered for more than a year and nobody was able to figure out that what her son is suffering from. And then she uploaded all the MRI scans and all of the result, all of the symptoms, one by one on ChatGPT, and it correctly diagnosed that boy. So think of an AI tool which has all of the medical journals at its disposal, all of the diseases, what type of symptoms it can lead to. It has better receptors to look at a CT scan or MRI scan, and it will be better at disease diagnosis. Last year, Google announced that they are developing an AI system which by scanning your retina can tell you that if you are more vulnerable to heart attacks. Turns out that if you have more vulnerability to heart disease, there are certain changes which happen in your eyes, which an AI system can intercept. So in disease diagnosis, in treatment, in clinical trials, in so many different areas, people are using AI in healthcare. So write down few things. AI in healthcare. AI in healthcare. Write down in bullet points. For disease diagnosis, AI algorithms can analyze medical images such as X-rays, MRIs, CT scans, to assist next. AI can speed up discovery of new medicines. AI can speed up discovery of new medicines by analyzing complex biochemical interactions. AI can speed up discovery of new medicines by analyzing complex biochemical interactions. Third, AI can be used for personalized medicine. AI can be used for personalized medicine. That is treatment plans based on patient's genetic makeup. ये क्वेश्चन में बार बार एक ही आंसर मेरे पास. एनी बुक recommendations for science and technology? I have answered this in the very first class. My answer is not going to change. So अब खाली आप एक काम करना, जाके आप एक Amazon पे सर्च करना कि AI पे कितनी किताबें लिखी हुई हैं, और जाके देखना, कोई भी एक खरीद लेना. अब वो एक किताब खाली पढ़ के आपको क्या पता चलेगा? AI के बारे में पता चलेगा. AI क्या कर रहा है, पोटेंशियल क्या है, चैलेंजेस क्या हैं, राइट? ओनली वन टॉपिक ऑफ ICT. And there are so many topics of ICT which I'm going to discuss. I have also discussed nuclear, I have also discussed space, I'm going to discuss defense, intellectual property rights. On all of these topics, books and books are written. UPSC के जो requirements हैं, बड़े specific, unique requirements हैं. Juxtaposing all of that together in a book, yes, there are books available in the market, but I don't think they are very good books, because they will rather complicate things further, and they will ask you to study even those things which according to me are not even required, or they are simply outdated. Because UPSC जो क्वेश्चन पूछेगी वो टेक्नोलॉजी से पूछेगी, टेक्नोलॉजी जो कि न्यूज़पेपर में मैक्सिमम क्वेश्चंस वही होंगे. कुछ कुछ क्वेश्चंस बेसिक साइंस के होंगे, वो आपका साइंटिफिक कॉन्सेप्ट अगर क्लियर है, जो आपने एनसीईआरटी पढ़ के करा हुआ है, उससे भी हो जाएगा आंसर. उसके लिए अलग से कोई बुक पढ़ने की ज़रूरत नहीं है. सो आई डू नॉट रिकमेंड एनी स्पेसिफिक बुक फॉर साइंस एंड टेक्नोलॉजी. वट आई डू रिकमेंड that read NCERT, that will help you a lot. I'm not saying that you'll be able to solve answers of UPSC question, but they will help you a lot. And take newspaper reading very clearly. And जो depth में हम class में चीज़ें discuss कर रहे हैं, हम ज़्यादा कर रहे हैं. In fact, lot of times we are going into a lot of topics, trying to make sense, like intuitively can we make sense of topic. वो भी ज़रूरत नहीं है बहुत बार UPSC को. Even a basic understanding of a topic with application challenges is more than enough for prelims and mains examination. So if you want to read books, there are so many other topics where you should read books. Read books of history, read books of geography, read books of polity. But यहाँ पे अगर मैं book recommend भी करूँ तो बहुत फ़ायदा नहीं है. So आप NCERT पढ़ो और आप newspaper पढ़ो, वो बहुत important है. That will help you a lot. Use classroom as a reference. जो classroom notes है, classroom discussion है, use that as a reference to filter out information from newspaper. Lot of information is unnecessary, and how to filter that out? Use your classroom notes as a reference point. That ये classroom में जितना detail में लिखाया गया है notes में, उतने ही detail में हमको चीज़ें discuss करनी है. And you'll be able to solve most of the questions. I'm not saying all of them, but most of the questions. But you have to do lot of homework by yourself also. Like इसीलिए मैंने बोला था कि साइंस टेक में आपको कंटिन्यूसली आपको अपडेट करते रहना पड़ेगा इन्फॉर्मेशन, पर थोड़ा एक बैकग्राउंड होना, ठीक ठाक बैकग्राउंड होना ज़रूरी है, सो दैट यू कैन अप्रिशिएट अ टॉपिक एंड यू कैन प्रिपेयर दैट टॉपिक फॉर यूपीएससी पर्सपेक्टिव. राइट डाउन वन मोर पॉइंट इन हेल्थ केयर. AI powered chatbots, AI powered chatbots can be used for remote monitoring of patients. Remote monitoring of patients. AI powered chatbots. आजकल बहुत सारे जो आप बातें करते हो आप कस्टमर असिस्टेंट से, देखा होगा आपने, चैटबोट्स हैं. So those chatbots are lot of customer care executive jobs, they are being replaced with AI. एक जो continuously हमको problem दिख रहा है, that AI can replace lot of jobs. So I'm going to come to the challenges part, and this will be one of the point that AI can replace lot of jobs here. Anyways, in next paragraph write down, in finance, AI can be used in remote monitoring of patients. Remote monitoring of patients. AI powered chatbots can be used for remote monitoring of patients. Write down next paragraph. In finance, AI algorithms are used in algorithmic trading. AI algorithms are used in algorithmic trading. Algorithmic trading, fraud detection, credit scoring. Let me explain the last two. Algorithmic trading, I told you, based on data, you are analyzing data, you're trying to predict how a particular stock market is going to move. in analyzing fraud detection. And I can give a practical example for that. Just last year, there was a news where finance minister announced that we are going to use AI to catch those people who do false house renting allowance claim. जैसे जब आप टैक्स भरोगे तो आपका एक HRA क्लेम होता है कि आप इतना रेंट पे कर रहे हो, एंड वो जो रेंटल जो भी आप पे कर रहे हो वो आपके टैक्सेबल इनकम से डिडक्ट हो जाता है. सो आपने मान लो 10 लाख आपका टैक्सेबल इनकम है, बट आपने 2 लाख रुपए रेंट पे करा साल भर का. So that 2 lakh month money will be deducted and you will only pay money on 8 lakh rupees. A lot of people who live in their own house pay money to their parents. That उन्होंने parents को अपना rent pay कर दिया, and they will claim that HRA. So what finance minister announced that we are going to look at such type of fraud activities using AI tools. Similarly, when in credit scoring, that based on your expenditure, based on your saving, what is your credit score? So that जैसे मान लो किसी बैंक को लोन देना है आपको, and bank is deciding that what is your credit worthiness, that will you be able to return that loan back to the bank or not. If you are a risky customer, then bank will often first will not give you lot of loan, and whatever loan will be given to you, bank is going to charge lot of interest from you. Versus a more trusty customer, bank will be able to give more loan with less interest rate. So even in such cases, that how to decide the credit worthiness, analyze my spending habit, my saving, all of that information, and that can be analyzed by an AI tool, and it can give a score that a trustworthy person who can be given loan or something like that. So this is also an application of artificial intelligence. Write down. In agriculture, AI is being used for precision agriculture. Precision agriculture. Precision agriculture, such as analyzing soil, weather, and other factors. For more precise intervention in fields. Write down next point. In education, for adaptive learning systems, grading automation, career counseling, AI is being used. One last, but again, this is not an exhaustive list. You can add many more things, but one last point you can add. In internal security, or simply in security, AI has applications in facial recognition. Cyber security, predictive data analytics, for crime detection, predictive data analysis for crime detection, among others. So I've only mentioned some of the most prominent sectors and some of the most prominent uses, but it is not limited to whatever sector we have talked about. Think of any sector, think of some of the challenges faced in that particular sector, and there are applications of artificial intelligence. In next class, we'll talk about challenges of AI. We'll also discuss blockchain in the next class. Last topic which I'm going to discuss here is some of the developments with respect to internet. That will conclude our discussion about ICT.